or network programmability, or what Cisco calls DNA, digital network architecture, requires that multiple platforms now talk to each other and share information with each other in predefined ways. And that's what an API is. It is that set of requirements that allow those two systems to talk to each other. And for a long time, humans were the only users. Back in the day when computers took up the entire room in a basement of a university, the way that we interacted with those was through, originally it was literally flipping switches, then we moved to punch cards, and then we got more advanced with keyboard interfaces and mice. And that was the interface, the programming interface into computers before that time. Now, we still interact with computers, otherwise we wouldn't be here today. So software displays the results of our user interface, or our UI, or our GUI that we're used to seeing, and that could be through our browser or our application. And then the user asks for data or takes action through that UI. Now, what we're doing with APIs is taking potentially the user out of that scenario, the human user out of that scenario, where the software itself interacts with another piece of software, and then makes decisions based on some programming that needs to be done through other languages, or through languages like Python or JavaScript, et cetera, et cetera. So it's really just a connection between two software systems. You can think of it like an electrical outlet. So, for example, if you had to plug something in, but there was no defined standard on how a plug works in an outlet, you would have to understand a lot about how electricity works. You would have to understand about how splicing wires together works. You might have to, depending on how your outlets are set up, you might need to know how to do some drywall and demo to get that open. So there's a lot of activity that goes into being able to plug something in that is saved by the definition of being able to plug into a socket that has a predefined definition. And the thing is, even across the world, we don't have the same definition of how electrical sockets work either. So there's some translation that goes on there. So, for example, right here, we're looking at a standard American wall outlet. And but if you are in Europe, or if you're in Asia Pac, or you're in Australia, or you're in England, even Europe to England is different. So there are translations that occur at those levels as well. And so whenever we travel globally, we bring adapters with us, and you can think of that as middleware layers that translate information from one software system to another. But there's a definition on both sides that middleware layer understands. And so that sets that expectation on behalf of the consuming software application on both sides. It's also, to give you guys another example of in the real world of what we're looking at here, it's a contract provided by one piece of computer software to another. Just like you would have with a screwdriver device, a Phillips head screwdriver will not have the same effect on a flathead screw that a flathead screwdriver would. So making sure that those definitions fit together is what APIs are appropriate for. And so then it lets us do these really interesting things as we move forward with software applications. And so, for example, an application like Yelp, they don't want to build out a mapping application. Google does a really good job of that. Why focus on driving around the world, setting up satellites, all of the pain that Google has gone through already to provide Google Maps? If Google Maps provides an API for that, and for all intents and purposes, I'm sure Yelp uses a paid version of the API, but if you're building out a mapping application, which I have done, you can use that API for free. And so for Yelp's aspect, right, why reinvent the wheel when someone else has already done this for us? So Yelp leverages the Google Maps API, uses that map data, ties that then to their application where they have restaurants and hotels and all the things that you can rate on Yelp. And Yelp can then focus on their user interfaces and actually providing ads for users, which is how they make money. They don't need to worry about mapping applications. They don't get anything out of creating their own mapping API or mapping application, they can just focus on what they do well and leverage what Google does well for their application. So we did receive a question here. So can we use Google Map API in Yelp? Yes, that's what I'm saying. You can use Google Map API in any application that you would want to leverage. And if you're interested in doing that, you can reach out, or you can simply Google Google Maps API. And let's actually take a look at what that means since we're on the fly there. Let me share my browser here. So if I wanted to, for example, use the Google Maps API, I'd head to Google, and I would type in Google Maps API, and I can find some documentation on how that can be used. And Google Developers is actually a really good site. They provide excellent documentation, and they provide a lot of samples. I've actually leveraged a lot of their samples to leverage their API. And we'll get into what API documentation looks like in a little bit, but the more comfortable you get with using what are called REST APIs, the more that the documentation makes sense. So that's just one example of how we can mash things together to build out very interesting applications. So if we're sticking with the Google Maps example, something like Uber probably uses the Google Maps API. Any Waze probably leverages some portion of the Google Maps API. Google has a lot of that infrastructure in place that people don't necessarily want to invest in, but they have an idea to build on top of it. So, and all Google asks for is potentially a fee then to leverage their API as part of those applications. And then, because they can mash these things together, APIs then become, as Programmable Web says, an engine of innovation. So because it's abstracting some of the really hard things that you need to do, then you don't have to worry about worrying about setting up the infrastructure, getting those base layers in place. You can come up with really cool ideas. So that's why Programmable Web says APIs are an engine of innovation. They aren't scary. You already use them. So as we talked about, human users interacting with applications through a GUI. For those who are network engineers, and because we're dealing with Cisco, that conversation always comes into play. Network engineers interact with the command line interface for their interaction with devices. And so, as you see on the right-hand side here, we have a bunch of commands that you would put into a router or switch to manage that particular device. And so that's one interaction that would happen. So that's a programming interface to a router or a switch. You can then extend that interaction through using script-like applications like Paramiko or NetMiko or Napalm to then interact with those particular languages or interact with those particular devices. Now, since the idea then is to build out automation so that you can replicate and recreate activities that a human could potentially run into a problem with because humans are inherently fallible, being able to leverage these types of packages like Paramiko or NetMiko or Napalm allows you to start automating these interactions with those devices. We do have a question in play here. Is Bootstrap one form of API since you use their predefined CSS functions to integrate to your web application? Yes, Bootstrap would be considered an implementation of an API, and usually the distinction is then called a software development kit. So when you see something that is packaged up like Bootstrap, that will be then called an SDK. So an SDK is a software development kit, is an implementation of an API, the application programming interface. So you'll see a lot of Cisco provided SDKs for certain languages. For example, we have ones for Spark. Paramiko and NetMiko have a Python SDK, for example, that implements their API, or the API that we're talking about here, into the command line interface. And so that's the distinction between the two. So Bootstrap, by definition, is an SDK implementing their web API. Good question. SNMP is also an API. It was designed initially as a programmatic interface between management, application, and devices. As you may know, if you are established network engineers, it's widely used for monitoring. It's our go-to protocol for keeping an eye on our devices. It doesn't have that configuration application, though, that would be needed for something that would be globally accepted across, or provide that controller functionality that we'd be looking for in a true software-defined networking world. It is a network management system's primary consumer. So those familiar with SNMP, that is in theory a API. There are some other APIs out there. One that is starting to go away is called Simple Object Access Protocol, or SOAP. It is a mature standard. It was designed by Microsoft. It had a lot of overhead attached to it. It allowed you to send information over HTTP or TCP connections, and the problem with it was both sides had to have a very distinct definition of what was going on, and it required a number of steps to actually package up the data that was being sent, send it, and then unpackage it on the other side. It actually made it very challenging for developers to wrap their heads around and to quickly develop with. And that's why at the bottom here it says sometimes it was considered complex and rigid. What is quickly replacing it, and has really become the industry standard as far as HTTP-based connectivity is concerned, is REST, which stands for Representational State Transfer. As I noted, it is an API framework intended to build simpler web services than SOAP. We'll see how quickly we are able to leverage a REST request and actually get information back from that. It is popular due to its performance, scale, simplicity, and reliability. And it is technically an API framework. It is not a protocol as something like SNMP would be, because there are implementation decisions that are left up to those who are actually building out the API. So something can be RESTful and look very different than another object that is also RESTful. So that's why it's an API framework and not a protocol. Just a quick note on frameworks versus protocols. The distinct definition of a framework is that it allows for the person that's implementing that framework to, or the team that's implementing that framework to have make some decisions at certain points on how they want to do things. With protocols, each time there's an implementation of that protocol, you will see the exact same activity for each one. And I'll point out some differences as why we call this a framework rather than a protocol. XML RPC and JSON RPC, remote procedure calls, are also our another API. Similar to REST, and kind of not a huge distinction between the two. The data that comes back tends to be in the similar format that REST also requires. REST provides data back usually in XML or JSON, although other formats can be supported. Going back to that discussion about frameworks. We also have netconf protocol, and this is our network configuration protocol. This was designed as a replacement for SNMP. It's been around for a while, and its last update was 7 years ago. It actually leverages SSH, so we're not going over TCP, HTTP. And the content that comes back is in XML. You would leverage this in scenarios where you need to talk to a device one-on-one. So that is our netconf protocol. And if you're familiar, it's tightly coupled to Yang, yet another, I can't remember what it stands for. I'm blanking right now. It's a snarky acronym, let's just say that. So So anyways, it's tightly coupled to the way that is laid out. And then the next generation of that is RESTconf, and this ties to REST APIs. So it provides a REST API-like interface to network devices. So SNMP starts going out the door working with our devices with the netconf protocol, and now, as you can see, it was just standardized last year, the RESTconf protocol, which will allow you to build interactive network configuration and management applications in similar ways that you would build out some high-level applications that would allow people to interact. For example, our Yelp application that we talked about earlier. So this is how we see the progression of network programmability, not just within Cisco, but within the industry as we moved. There we go. Thanks, Carl. Yet another next generation was what Yang stood for. A little blank there on my mind, so I appreciate the information. So now we're leveraging HTTP connections into those devices instead of going through. With RESTconf, what we saw was SSH. Like I said, it stands for representational state transfer. It's built over HTTP. You will hear the term REST and web services used interchangeably. And again, it's popular due to its performance, scale, simplicity, and reliability. It supports the common HTTP verbs, get, post, put, and delete. Get usually, or 99.9% of the time, is grabbing information. So if you make a request to a web service or a REST API, you're going to be getting information back. Post, usually, I would say 90% of the time, is to create a new record in that web service. So there are instances where the API will allow you not just to query data, but to create new data to be managed by that web service. We also have puts that tends to update data that already exists. Sometimes you will see post and put used interchangeably, or one replacing the other in the API definitions. It's not common. But just to give you a heads up that you might run into situations where you would expect a post to be used, but instead you'll see that a put is used instead. And then finally we have delete, which is pretty self-explanatory, and 100% of the time it's always delete. So those are our four main HTTP methods that the REST framework implements. This is basically how it works. The application that our guys using here is making an HTTP request to our web service here. It's asking specifically for the endpoint hello. Our endpoint does something. Our web service does something. Our REST API does something. What it does, we don't care how it does it. It's a black box to us. We're just making a request for that to do that activity. So that's what those gears are indicating. It does its thing, and then it sends back a response. Now for gets, it tends to be a payload of data. For puts and posts, it tends to be an indication that the request to update or add information has been completed successfully. And if it's a delete, in a similar fashion, there's an indication that that activity has completed successfully. So it's a pretty simple interaction. Now a lot goes on behind the scenes in that particular space. So those little gears that we have there, that a lot could be happening on that web services side to create that response that's coming back. So let's take a little bit closer look at how this is all laid out here. So we have the Google Maps API that we had talked about earlier. The web address for it tends to be the server or host, or is the server or host for that particular service. So that's the web service that we're looking at. The middle bits are our resources, and then anything after a question mark there in red is what's called a query parameter. And so that allows us to update the or filter the requests that we're making. So if you want to compare it to maybe a SQL query, anything after that question mark would be your filters on that request. It is supported over HTTP or HTTPS. I would be wary of APIs that don't use HTTPS. as then that data is being transmitted in the clear. If it's not mission critical data or it's not sensitive data, that's okay. But if it's something that you want to make sure is not able to be seen by packet sniffers, I would highly recommend only using APIs that provide data over HTTPS. Let's take a look at it, and you guys can follow along with this. I'm going to actually grab this URL and show you guys what it's like to actually make this API call. And I'll put it in the chat so you guys can copy and paste it as well. So in our browser, making an API call is as simple as, especially a GET, you can't do really put and post in your browser, but we can make this API call in our browser by putting in our URL, and now I'm getting an error message. Let's try another address. There we go. So I live in Cleveland, Ohio. So now I'm getting this data back in what's called JSON format. We won't delve too much into that. That's for another day. But I've made a request to this API. It gives me my address components that then I can leverage to build out an application that parses this data, that does some action with that data. I don't have to maintain the data myself. I just need to make that API call. I didn't have to authorize this API call because it is freely and publicly available, although it looks like there are some limitations on how often we can make those API calls, and I'll talk about that in a second. So this is our first basic API call, and as we can see, it's pretty simple to actually start getting your hands dirty in these things. As we noted, we support those HTTP methods. The other one that's on here that we didn't see before is patch. Similar to puts in their function, it is used to modify some details about a particular resource. Depends on what that API is. Most APIs don't leverage patch, but again, it's one of those things that if you're looking at the documentation, it'll tell you what you're capable of doing. Status codes, how did it work? So a lot of times you'll hear the notion of 200 OK. That means everything has worked as expected. The API call that you've made or that the application has made against the web service or the REST API has completed successfully, and everything that has been returned is something that should have been expected by the application or user. Sometimes 404 is not found, and you'll see that in web services that don't have the page that you're looking for. For example, we'll head to a service called GitHub, and I will show you, hopefully, what they do with their 404s. I don't have a repository called Pizza Pie, so I should get a 404 error. So similar to what you would get when you browse to a page that doesn't exist, you will get a 404 response when you make an API call that doesn't exist. So that is the same indication. Now there are other errors that we can run into. If we're doing a post or a put, you might get a 201 created or a 203 updated. If it's a bad request, so 404 means it's not found, but 400 means you've provided invalid information. Your query parameters aren't accepted. Or if you're doing a post, you haven't formatted the data correctly when sending that data over to the service. That's when you'll see a 400. 401 unauthorized is one that commonly occurs, especially when you're starting to use an API. APIs, REST APIs specifically, have a number of different ways that you can authorize calls. So, I think we'll talk a little bit about that in a second. But if you don't authorize your API call successfully, you will get a 401 unauthorized. 403 means you are understood to be noted as a user that can make an API call, but that particular one is not allowed to you. And then, so that's our 400 series. And then our 500 series, if you receive a 500 error from the service, something is going on with that service. It's not likely something you've done. It's not likely an error that you've made, but that service is having an issue. So ideally, in a perfect world, all of your API calls will result in something in the 200 series. Occasionally, you might run into issues where you get a 400 series where you need to in your code and adjust accordingly. And then if you have a 500 series, again, you will need to take that into consideration in your code. There's likely nothing you can do about it other than call the support desk and say, hey, I'm getting a 500 error when I make this API call. Now, for all of these, the general message is the same, but the implementation of them varies from API to API. There can be instances where you'll get a 401 unauthorized, and it'll tell you exactly what you've done wrong, why you aren't authorized. If you get a 500 error, sometimes that internal server error, sometimes you'll get a 500 and it'll tell you that this service is up and running, but there's something, this is what's going on. So it just depends on how that service implements these status codes. But these are well-known status codes, and you won't see anything different than that. Occasionally, you might see a 300 series where you have redirects. That is a very rare occurrence, and I can only think of one off the top of my head where you need to take that into consideration and follow the 300, or I think it's a 301 redirect in this particular instance, where you follow that along to actually make the API call. So put that one in the back of your head just in case you run into it. But these are the ones that you have to take into consideration every time you are implementing an API call in your code. You also have to deal with headers, details and metadata of those headers. Mostly you will see either content type or accept for the type of data that you either want to send to a service or receive from a service. More and more, we're seeing that JSON is becoming the standard. A lot of services still support XML in some way, shape, or form. Specifically for RESTconf, you can get the data back in XML because netconf and RESTconf support that, and the devices that we're actually talking to support that. But a lot of our web applications that we see out on the internet that we'll be interacting with support mainly JSON. And again, these are just data formats. JSON stands for JavaScript Object Notation. Takes a lot of the overhead off that XML actually has. And I think one of our classes later will actually deep dive into dealing with JSON and XML and the advantages and disadvantages of each. We'll also see an authorization header if that API requires it. The most basic version of that is actually called basic, and we'll talk about that in a second. And potentially you can get a date and time of that message to track that, or to be able to log how long things are taking, to be able to provide logging for later usage, or if you're tracking something in a database, you can provide a date to that as well. These headers are provided in the request and the response, and the API documentation will tell you what is required to put into the request. Oh, and one other note here. At the last bottom bit here, it says some APIs will use custom headers for authentication or other purposes. Content type, accept, authorization, date, those ones are all defined as part of the HTTP protocol, but HTTP allows for custom headers to be sent. So, for example, I mentioned earlier that I'm the Meraki developer evangelist or developer advocate, and Meraki uses an authorization method where you generate an API key on their service, and you have to use that for all API calls against that service. And it doesn't matter what that service is, just know that it's the Meraki service. And they use the custom header called X Cisco Meraki API key. And they define that as the accepted header and the value, and then their service looks for the value that's provided as part of that header to authorize those API calls. So that's where the custom headers notion comes into place. Sending and receiving data. So if you're sending data, it's contained in what's called the body. Post, put, patch requests typically include data, and the format is typically JSON or XML. and the content type header will determine whether or not you can send JSON or XML or both. This is a small example of JSON. It's at its base level, it's name value pairs. There's no definition required for those particular sets of information. It's actually designed to be pretty human readable, but it's also very easy to parse in programming languages, specifically Python, which is why we push Python so hard. And in this particular instance, we have an object that is tied to, for all intents and purposes, a book with the title of Hamlet and an author of Shakespeare, and that is encapsulated in curly brackets. And so you can imagine a scenario that if we were asking for a library of books, that we would have multiple books that have title and author tied to them. Some notes on authentication and security. So initially I talked about basic authentication, so what we saw an example of none. We just make an API call in our browser and get data back. That was our Google Maps API call. There's also basic HTTP. This is actually pretty commonly adopted across some on-premise managed services. So for example, our Cisco CMX service, this is usually a service that's deployed on-premise. It's not cloud accessible, and it provides a way that you add users to the actual service, and they are provided with a username and password. That username and password to authorize API calls is concatenated with a colon and then base64 encoded, and then sent with basic space and then that encoded string as part of the API call. So that's basic HTTP. I actually have an example of that so you guys can see it. So one second, let me share this application. And this is actually a good segue into our tools. So this is a tool called Postman, and you're going to see this a lot as you delve into DevNet content. Postman is all over our learning labs, learninglabs.cisco.com. They provide us a way to make API calls with assuming that this is the system endpoint, the application endpoint. So what we did in our browser initially was we made our Google Maps API call. I can actually make that call in here, and I'll show you guys how to do that. So I'm bringing in the same API call that I called before, but it gives me a lot more information than what I could see in my browser. So if I hit send on that, and they're not liking the amount of times I make this API call. There we go. Now I can actually inspect the headers that come back. I can actually take a look at the body in a more conducive manner. It tells me my status, 200 OK. That's all the fun stuff that comes back from an API call, and we'll dig a little bit deeper into it. But I wanted to show you guys an example of basic authorization. So we have our URL, we have our method that we're making a call to, and I'm asking for the endpoint for CMX. This is connected mobile experiences. It's tracking devices in a space. So I'm looking for Wi-Fi devices on a map. If I go to the authorization, or the headers, the authorization, it'll ask me for my username and password, and then I'll show that password. I'm using basic auth. If I hit send, it'll go out and make that call. I hope this is up and running. It is. Okay, good. I get that data back. If I look at the headers, though, it set up my authorization, basic space, and then this base64 encoded string. And now if I were to take this to a base64 decoder, it would say the username and password learning:learning. So that's our implementation of the basic authorization. I did see some questions come in, so let's take a look at those real quick. So the question was, is there a kind of cheat sheet to summarize all the APIs you are covering, including tools available for a simple, quick test? I will be providing this deck to, this deck will be provided, to you guys as in searchable, so you should be able to pull this information down after we're done. So moving on, we have the HTTP, or we have a token implementation. or custom implementation. This is kind of open to interpretation then for those creating the API. So, for example, our network management controller APIC-EM uses a situation where you pass in through a JSON body the username and password, passes that to the actual APIC-EM service, and it generates a token for us. Similar to what I explained about Meraki. You use the X Cisco Meraki API key that you generate in their dashboard, in their web dashboard, put that into the API call, and make it move forward. Now again, all of these things are defined in the API's documentation. So if you're using a new API, the first thing you're going to want to figure out is how is this API call authorized. The last one that we do talk about is OAuth. OAuth 2 is becoming the industry standard for web services. So if you are using the Twitter API or using the Facebook API like Cambridge Analytica did, if you're using the Google Maps API, actually they take a key, so I take that back. So Facebook, Twitter, I know do that. GitHub does it. We provide an OAuth implementation into our Spark service. This is basically a two-way handshake where you're provided with an access token that then makes a request for an authorization code, and then allows you to, well, you use a client credentials to get an access or to get an authorization code to get an access token. So it is an involved framework process. And again, that is also a framework because it does leave some interpretation open to the those doing the implementation. So keep an eye out. One OAuth implementation to another can alter how you leverage that API. Cisco Spark has a pretty good definition of that. So if we go to developer.ciscospark.com, that's not right. There's a change that I did not know. So 1 second here. So anytime you see a scenario where it asks for your email or it allows you to log in different ways, it will provide you with, that's an OAuth 2 implementation. Let's take a look at it. So now Cisco Spark for Developers is now Cisco WebEx for Developers. I was not made aware of that, so I apologize. The implementation tends to be the same. So if we look at our guides and we look at the API reference, let's take a look at rooms. So this is a good example of good API documentation. Cisco Spark is set up in the concept of rooms, so all of your interaction occurs within those rooms. So we can actually take a look at what that room interaction through the API can do for us. We have our content type headers that we talked about before. We have our authorization. Now we're provided with a bearer token. So this indicates to me that they have OAuth 2 implementation because the term bearer ties to that implementation. I'm given an access token as part of my login credentials, and so I can make those API calls within the documentation. But if I was setting up a scenario where I was implementing Spark into my web application and I wanted it to set up authorization for each individual user as they interact with the Spark service, I'd want to make sure that I provided the OAuth 2 implementation as defined by this service. So that is, for this particular instance, is laid out in the integrations area, and it'll tell us about the OAuth service. What do I need to provide to authorize API calls for people who log into my service? So that, we could spend a whole day on walking through a tutorial on that. I just wanted to make you aware of the different ways that you can authorize API calls. You are accessing a service that needs some security behind it, And so there is a predefined way that you interact with that service. Examples, my colleague who put this together, he likes to use the Internet Chuck Norris database. For those of you around the world who do not know who Chuck Norris is, he is a TV and movie star in the United States, and he there is well known that he is the toughest guy in the world, according to us. So if we take a look at that particular API, let's see here. Let's see if I can grab this text. Let's just create a random joke for us here. So if we make that API call, I've set my method to get. I'm just asking for a joke at random. And that's their definition of how they've implemented their API. And it says there's no such thing. Okay. The probably inappropriate joke for this audience. So you take a chance with the Chuck Norris database. Let's move on. Pay from the current slide. And I can pass in variables as well if I want to limit them to nerdy ones. They have different categories. Let's actually take a look at what this URL takes us to. This is the definition of the API for us. So it gives us documentation on the endpoint, the server that's there, the content that's going to come back. This is actually a really well documented API. We can change the name of the character, fetching a random joke. So this is similar to what other documentation for a serious API you might see. Now, getting into network programmability with RESTconf, because these are tied to Yang models, again, yet another next generation, as my brain decided to kick out earlier. It provides, so that supports basic authentication, which we know. What you're looking at here is what's called a tool called curl. Curl is a command line interface that allows us to do similar activity to what we saw on, to what we saw in Postman. And we'll do a quick example of that, and then we'll call it a day, because I think we've covered everything we wanted. But let me grab this particular call here, and we'll see this in action. Let me share my console here. Make this a little bit bigger so you guys can see. I'm going to paste in what I just copied. Hopefully it pastes in right. So this is actually making an API call to our sandbox environment located at ios-xe management.cisco.com, port 9443. And then the layers here that we see in the resources is tied to that Yang model. So RESTconf data, IETF interfaces, interfaces, and then we're looking for gigabit Ethernet 2. It's making that call to that particular address. I have verbose tied to it, so that's our -v. And then it's telling me everything connected okay. And finally, here's our payload that comes back, and it gives me information about our gigabit Ethernet 2 interface. Not a ton of interesting information here, but it allows us to see that we can make our API calls in multiple ways. We saw it through the browser. We saw it through the Postman client. We saw it through curl now. A bunch of different ways to allow us to do that. So let's just make sure before we shut it down here that we've covered everything that's pertinent. We talked about many options for interacting with the APIs, and then so that's that. Let me check the questions here before we go there. Jason Wang asked, hi, can you explain how learning API, Python automation, and other advanced technologies will be useful for the next generation of network engineer? Excellent question, Jason. So the reason that we're providing these courses over the next 3 weeks, and the reason that DevNet exists, is that there is a move, and it's going a little bit slower than I think that we expected it to a few years ago, but there's a move from the network engineer managing everything directly on the device through the CLI to a situation where we are able to manage thousands, if not tens of thousands, of devices across the entire world through APIs and automation. And it doesn't necessarily need to be super complicated web applications that are doing this automation. They could be command line scripts that we are running from our laptops. I can update the configuration of consider a scenario where I can configure or update the configuration of every switch and router across my global WAN, where I know that as those configurations are applied, each one will be correct and proper because I didn't have to go into each one individually at 3 in the morning while I'm tired and make a mistake on the ACL list that's allowed to leverage those particular devices. So that's why we're pushing forward with this. That's why this stuff is important. It doesn't necessarily mean you're going to become super software developers and you'll be able to write all these crazy applications that seasoned developers that have been working on for decades would do. But it just might make your job easier and more repeatable across the entire network engineer spectrum. So that being said, please join our session next week where we will start an introduction to Python, and I will actually tie together what we learned today with how we would implement that in a programming language. And then we'll delve a little bit deeper into that Python and REST API mixture in the third session as well. As well. The agenda today is to talk about why we're even talking about Python. There are a myriad of programming languages out there available to us. Why do we focus on Python, specifically at Cisco DevNet? And how do you get it? We'll take a look at some Python code, some of the parts and pieces of it, the baseline parts and pieces so that you understand what we're looking at when we get into the examples. We'll take a look at interacting with Python Live. Python, unlike some other languages, has a command line interpreter that you can use, and we'll take a look at some examples and why that would be useful. Then we'll talk about libraries and how to use them, and then we'll figure out how to install those libraries with a Python included tool called pip. We will wrap up with virtual environments and then foundational libraries as well. So it's an action-packed hour, so hold on to your seats. You guys will be partial developer nerds at the end of this, so sit back, relax. If you want to follow along with some of the examples, you can, but I encourage you to pay close attention and then take what we've learned today and go out and try these things for yourselves. All of the code that we're walking through, all of the examples that we're walking through are available online. I'll provide links to those at the end of the session. There's actually a video series as well that expands upon what we're looking at today. This comes from a session that we call Network Programming Basics, and so this is just the introductory piece. So if you're interested in going out and looking further into what we call network programmability, that would be a good session for you as well. So I'll provide links for those at the end. So to start off, why Python and how to get it? Python is what's called an interpreted language. It's not compiled like some other languages. It is powerful and fast. It is really good for interacting with other forms of software. So, for example, I will give you one good example today. This morning I was working on an application that was using Python as the back-end server. The front end was JavaScript. and in between that we had some HTML. So I was able to pass information between those three levels to allow me to build a web application with the baseline application software being built in Python. You can run it everywhere. It runs well on mobile devices. It runs well on servers. It's supported on local laptop machines. Pretty much if it's a computer, it can run Python. It has really good support along cloud services as well. So if you aren't interested in hosting your own applications and you want to put them on something like AWS or Azure or Heroku, or you want to build out Lambda functions on AWS or Google Cloud, which Cisco is a partner with, Python is a good language to get started with on that stuff as well. If you're familiar with microservices and containers, these are advanced software development topics, but as you get more and more involved in network programmability, you might see these things crop up. Docker and Kubernetes provide platforms for running Python as well. So it is a very versatile language, and really the biggest part of it is that it's easy to learn. We're going to see very quickly that within the next hour, you'll become very comfortable with at least reading Python code. It takes some time to actually learn how to write it because there are nuances with anything. It's like learning a foreign language. I know we have a lot of people around the world that speak English, otherwise you wouldn't be on this webinar. But for me, shamefully, English is my only language, and for me, learning another language like French or Spanish or Chinese would be a lot of work. And similarly, learning programming languages have that similar learning curve. The logic behind them kind of stays the same, but Python strips away some of that learning curve, makes it easy to figure out how to do some very simple things where other languages make them a little bit harder. And it's open. So a lot of the community around Python is very collaborative. They share code very readily. A lot of projects that we start on, we do not start from scratch. We will grab existing Python code and build on top of it. So it's a very large, robust community that, especially within network programmability, where Cisco and DevNet live. So that's why we use Python and start to teach a lot of our programmability concepts outside of Python. Excuse me. It is very easy to read. For those of you who may have some history with JavaScript, I like to compare Python to JavaScript because for building out applications, those two languages kind of go well together. But JavaScript is hard. The syntax and the semantics around JavaScript make it very challenging sometimes for people to understand. And I've been doing this for 15 years, and I still have issues with working with JavaScript. I do not have those same issues with working with Python. Pretty much the code that you see, you can wrap your head around pretty quickly. Like we said before, it's widely available in open source. You can run it on Windows machines, Macs, Linux. We actually have devices, networking devices, routers and switches that have servers now running on them that support running Python as well. So you can start doing things like edge computing activities on the routers and switches within the network rather than having to centrally locate the logic and applications that are running. There are tons of relevant code samples. And we mentioned libraries in the agenda. There are libraries that help you do a lot of the heavy lifting, and we'll take a look at those libraries in some of the ones that revolve around network engineering in the next session next week. But there are a lot of libraries and code samples available to you to get started. But the whole idea is that you're comfortable enough with working with Python that you can go out to one of these tutorials. If you Google Python tutorial, you will find thousands of them available to you, and probably any one of them would be very useful. So if you want to become a Python expert, a Pythonista, there's a lot of training sources online available to that. We're just skimming the surface here. How do you get Python? If you head to python.org/downloads, you can download it there. For those who have Macs, you probably already have it. Python 2.7, I believe 2.7.x. I'm not sure what the last version that comes out with the OS X Sierra, but that is installed natively, usually on Macs, 90% of the time. If you don't have it installed, you can install it with Homebrew. Brew install Python 2 if you need version 2. Brew install Python 3 for version 3. For Windows users, just like everything, when dealing with development environments, Windows users, things can get a little tricky when installing Python and using Python. The best tip that I can give you is that when you're installing Python onto a Windows machine, that you should make sure that you check the box that adds Python to your path. For new developers, those that are just coming into working in software development, being able to run your applications is key, and understanding what your environment variables are is also key, and being able to understand what your path is and how that's set is key. So when I say path, I mean the locations of the applications that your laptop or desktop or server knows where to run applications. So if you are installing, Macs are very good about setting your path properly when installing applications without any intervention. But with Windows, a lot of times you have to tell it where you're located. So that is one huge caveat I cannot stress enough. When you're installing Python on Windows, make sure you check the box in the installer that says add Python to my path. Otherwise, you'll have to navigate to your Python install directory to actually run Python, and that's a giant pain, and we don't want to do that. So that's what's going on there. That's how we do the install, pretty straightforward. Let's check the Q&A there, just to make sure that we're covering everything. Let's see here. Mohammed asked, how do you say it's open? Can we create and customize our Python syntaxes? You cannot customize your Python syntaxes. Python, just like any programming language, has its own defined syntaxes. So no, you cannot do that from an open standpoint. It's open because there's a lot of collaboration around it. And you can submit to the Python organization. It is an open source organization, and so if you find issues with the language that you would like to update, you can submit to those, but you cannot create your own syntaxes with the existing versions of Python. Is it possible to compile and execute? I also answered that. No, you cannot compile and execute Python code. You can convert Python code with some conversion applications to something that is compiled. But Python in and of itself is interpreted. The question, do we still use the 2.7 version? That's a great question, and before I move on, I would like to take a minute to answer that. So Python 3 has been around for a few years. Python 2.7 has been continually updated in parallel with Python 3, and had you asked this question about a year and a half ago, I would say you tend to err on using version Python 2 because the Python 3 version was unstable. There would be situations where people were porting pretty significant amounts of code over to Python 3 and finding it wasn't running as optimally as it did in Python 2. So there was a lot of holdover from Python 2 to Python 3. Python 2 and Python 3 are still being updated in parallel, but more and more often you're going to see applications written specifically in Python 3, and we're seeing a shift over the last year or so in focusing on Python 3. Now there are instances within Cisco even where Python 2 is a recommended version to use, and in those instances where we're working with a library, an SDK, or an API, it will be called out specifically in the documentation which version of Python would be useful to use. So that is an excellent question from BJ. Omar asked, does Python run in smartphones? Yes, it does. Let's see here. Let's do. All right, code. So we'll jump between slides and my development environment so we can actually take a look at that code. In this first example that we're going to look at script structure and format, importing and using packages or libraries, variable declaration and usage, function creation and usage, and some basic error handling. So I'm not a big fan of slideware, so let's hop over to my development environment here and we'll take a look at example 1. So 1 second while I load that up. Alrighty. So we are looking at, and I will provide you guys a link to download this code from GitHub if you would like to take a look at these examples more closely, but I will walk through them right now. At the top here, we see a common way for commenting our code. For those of you new to software development, commenting your code is absolutely key. It helps developers that are then using your code in the future be able to read what's going on without having to do a lot of thought. It helps people that are implementing your code as well. So giving a description of what this file is doing is a good, best practice that we'd like to point out. We can also call out specific authors. So I did not write this code, and I will not take credit for it. My colleague Hank Preston did, so I will give him the credit for it. And he can call out his specific author email address, copyright license. We can define any file level variables with the underscore, and then the variable name, and then underscore. And we'll see how those are useful in a minute. As we walk through this code, so this is what we would call a Python script. It's not a full-fledged application. It's something that does something very simple. Actually, I've jumped ahead here. Sorry, this is the one we want to look at. It does something very simple. For those of you who are network engineers that are transitioning into software-defined networking or network programmability, a lot of what you're going to be doing is going to be in the scripting realm. And that, for all intents and purposes, it's a loose definition, but what you would be doing is writing applications that potentially interact through our REST APIs that we talked about last week with devices or network controllers or some other endpoint, and do something relatively simple. Maybe you're changing some information on the fly, or you're taking a bunch of devices and updating their configurations, and then that application is stopping, or that script is stopping. It's not something that's running constantly on a web server. It's not something that will be potentially running on a mobile device. It's not a full-fledged application. So when you hear the term scripting, it tends to be a really small, self-contained piece of code that is able to be run usually from the console, and we'll actually see how these are run today. So that's what we're looking at. We're looking at scripts as we walk through this. The first line of code that does something is importing our systems library. Import is a keyword that allows you to pull in libraries into your application. Sys is one of the, and we'll actually take a look at Sys a little more closely later, but it allows you to tie into some console-based interactions. The first thing we come across here is our function definition. So in other languages, you will see the function definitions offset with curly brackets. This function, or Python functions, are offset with indentation. You will only see curly brackets when you're dealing with what are called dictionaries, and we will cover that in next week's session with dealing with data structures. So indentation is very key when dealing with Python. When we're defining functions, if you want to get into things like object-oriented programming, if you're defining classes, classes are offset by indentation. Conditionals, so we see an if statement down here. That's offset by indentation. Indentation is totally key. So, for example, if I were to remove the indentation from this last line here, first of all, I would get an error because the indentation is wrong. So as Python goes through the code and interprets what you've typed, it will make sure that you haven't made any syntactical errors. And in this instance, what will happen is if this return now exists outside of our doubler function. So for this return line to work properly, we have to make sure that it's tabbed within our function definition. We can also, so we set the name of our function, so this is up to you, whatever that function does, and then we pass in variables. And you can pass in any number of variables that you want. Now, with other programming languages, you're going to run into a situation where you have to make sure that the type of the function is identified within the function definition. With Python, it is what's called loosely typed. You do not have to, actually you can't, there's no way to do it. Whenever you create a variable, you do not give it a type. You do not call it an integer. You do not call it a float. You don't call it a string. You just create the variable and assign a value to it. So in this instance, we were passing in a variable called number, and we'll see where that's called. But within this function, we're creating a new variable called result, and we're multiplying that number that's passed in times 2 and then returning that result. Now, when that number is passed in, depending on if the number that's being passed in is an integer or a float, will change the type that result is. So you don't have to worry about it. This is one of the really nice things and why Python is a lot easier to use than other programming languages, is that you don't have to worry about the type of the variable that's being generated too much. When we talk about data structures next week, we'll get into a situation where we talk about having to understand the difference mainly between strings and objects. But as we're talking about individual variables, when we're talking about Booleans, so true, false, numbers, so numerics, so integers versus floats, or decimal values in strings, that's where the variable loosely typed set of Python comes into play. So we don't have to worry about those things, which you can see this in the code as we're looking at it right now. So this is our very simple function that multiplies our number by 2 and returns it back to wherever it was called from. This is a common entry point setup for a script or a program. It's looking specifically for if underscore name underscore equals the string underscore main underscore. So this is a common entry point for Python. And the reason that this line potentially exists is that when you're dealing with multiple libraries within a Python application, there could be scenarios where some code could be stepping on each other if you don't call out specifically that this is the main function and then everything else that's being used is the library. We also see another concept in here, which is a try and except clause, or in other languages, sometimes it's called try and catch. So in situations where you are dependent upon user input in this instance, or specifically where we run into issues with this in the coding that we do, is leveraging REST APIs. So REST APIs are dependent on making HTTP calls to other services that you don't control. And so under the assumption that it's up and running most times, you will try to make that API call. And if it succeeds, then you proceed further along with what you want to do. Unless you get a 400 error or a 500 error, the service is down, something has gone wrong in this API call. In that instance, you will hit the accept clause, and in that instance, then you will take some kind of action. I call this, and I've heard other people call this, making a graceful exit out of the application or script. So there are instances, so if we just did this try, we hadn't input any information and did not wrap it around a try except clause, it would just crash our application. So there could be instances where you have scripts that you want to identify what the error is and move on, or you want to make sure that you prompt the user for some specific bit of information. You want these things to happen. So you will put the error handling code in the accept clause. So the try is, this is what we want to happen all the time, but we understand that there are instances where these things can happen. So this is our contingency plan. This is the accept. In this instance, all it's doing is telling us that we need to provide a value when we run our application. Otherwise, we will exit, otherwise we will exit the application. So within the main function, the entry point for the program, we're creating a value answer, creating a variable answer, and then we're calling our doubler function and providing that input that we received up here. This sys.argv1, that is going to hit the command line value that we actually pull in, and we'll take a look at how that works a little bit later. We're going to call doubler, set the value that we returned, this result, back to answer, and then we're going to print out the answer if we do that. But I want to show you guys how the try except works, and so let's pop open our command line here. So 1 second. All right. So let's make sure we're in the right directory. Blow this up so you guys can see. And we are currently in Programming Fundamentals. And we are in Python Part 1. Okay. So the first one we're going to run is example1.py. So I have 2 instances of Python on my machine. So I'm going to, Python 3 kicks off the Python 3 version on my machine, and Python, just the word Python kicks off Python 2. So I'm going to type in Python 3, and I'm going to run example1.py. Now I'm going to get an error because I'm not going to put a value in for it to actually evaluate. I handled that error in my accept clause, which is what we saw in the code. You must provide a number as a parameter to this script. And then it gives me an example. So let's do 45.4. So it performs our action and it exits out. We've just run a very quick, simple script that doubles our value for us. Okay? Let's see here. Let me take some questions. I'm going to work backwards. What if we provide string as input? Oh, that's a good question. Let's try that real quick and see what will happen. So it tells us we must provide a number, so it actually evaluates that error for us. Tandra asked, in the Windows environment, there's always a problem while running Python from any directory. Can you speak on this? That goes back to my notion about making sure that Python is set up properly in your environment variables, specifically in your path. I will provide a link to the demo files at the end of the course. The question is, where can I download these demo files? Let's see. All sessions are arranged on the 3.x version. Let's see here. I am using, some questions that come up to the development environment that I'm running. This is Atom. It is a pretty powerful development environment. There are dozens of development environments available to you. But I don't want to get bogged down in which development environment I'm running. All right, so just hit a couple of questions there. I'll try and answer as many as I can as part of this, but we will jump back into the session flow to make sure that we cover everything. The question did come up, where are we calling the result attribute? So to follow along the code in direction, so the code is running from right here. If name main, it's taking the input from the command line, the sysargv1, setting that to input. If we put a number in, it will take that input and pass it to the doubler function, which jumps up to here, doubler number. We're taking that number value that we've added in. So in my example is 45.4, multiplying it by 2, getting our result of 90.8, and then hitting return result. Now that return is going back to where we called the doubler function, and it's setting it equal to this answer, and then that's where we print out the answer. Okay, so that's the way that we're walking through the code. Ready? Jumping back into the next example. So we covered function creation and usage, variable declaration and usage. We will talk a little bit more about importing and using packages, although we did touch on that, and some basic error handling with our try and catch. Let's see here. Now we're going to look at reading and writing from and to files. We're going to talk about the with statement very quickly. We're going to request interactive user input and then writing to the command line. So the next file we're going to look at is example2.py. See all the same kind of information that we saw before, but now we're bringing in our datetime functionality. So there are two ways that you can bring in functionality from other libraries. You can pick out specific pieces of that particular library, or you can import the whole library itself. So depends on how much overhead that you want to put on your application to do that. So in this instance, we're just importing the datetime functionality from the datetime library. We are creating a log file name, example2.log. So this isn't actually creating the file, it's just creating a string variable that we will use later to create our file. We have a couple of functions here, but I'm going to start at the main entry point and then jump to those areas so that you guys understand the flow of the script. So again, we see the entry point for our program if name equals main, name, and then we're asking for input. So this is a reserved keyword within Python, input, and this basically tells Python, wait for a prompt from the console. So this is going to actually ask us, what is our name when we run this application? And we'll type that in, and when we hit enter, then it will move to the next line of code, which is print, adding a new log file entry. And then this is where it actually creates our log file, and well, it creates it if it doesn't exist, and then adds in our name to it. So write_log is going to do that for us. We don't have to import any packages for this to actually occur. So write_log is another reserved keyword within Python that allows us to write this information to a log file. Print is also a reserved keyword that prints up to the console. write_log, and read_log are native to Python, and they're reserved keywords. So, oh, I'm sorry, they're not. That's not true. write_log is a function that we defined earlier. Ignore everything I just said. I didn't have enough coffee yet today. So write_log is going to go to our log file. We will jump up and talk about what those things actually do. There is a little bit of a nuance, and I don't know if you guys can see this within the share, but this input is like an aqua blue, and write_log is a light blue. Input is a reserved keyword. write_log is our function definition. So ignore what I said about write_log and read_log. I apologize. That was a mistake on that comment there. So write_log is actually going to jump to our function definition. We're going to pass in that log file name that we created earlier, or log file, in the name that we've typed into our console. So log file, which we created up here, log file, and name. Then we're going to print that out. So then we go up to write_log. It's passing in that log file name and our name. We're going to set up the log time using the datetime.now function. So datetime, then there's documentation for all of these functions on python.org. Datetime.now will tell us the time it is right now in a specific format. You do have to convert that to a string because it is an object. And we want to write that string to a file. And so any functionality that then happens after this with statement will apply to our log file here. And then it's referenced as F. So what this is doing is it's opening our log file, it's setting its state to append, and then it is assigning that log file a variable so that we can perform certain methods on it. So with open log A as F, and then anything within here we can perform certain functionality on it. So in this instance, there's f.writeLines, which will allow me to write the log time in my name that I've entered into that particular log file. So writelines is a method that is tied to this object F. So F is a file type, or is a variable type of file, and that has certain methods that are available to it. One of those is writelines. Again, this is documented on python.org, and will allow us to write the line with one simple line of code. So we write our log, we print out an extra line so that everything looks pretty when we're on the console, and then we're going to read those log file contents. So writelines was one method that is available to us, and we'll see another one that is available to us called read. So now we're just passing in the log file. Again, similar as we saw with open A, so A stands for append here, and now we're going to pass it R, so we're only opening the file to read that particular file, setting our file object as F, and now I have methods available to me to access that file. In this instance, I want to just read it, so f.read. Now, if I had opened this particular log file with R down here, I wouldn't have been able to write to it. I would get an error because I haven't opened that file in the read-write method to allow me to actually append to that particular file. Okay, so some pretty simple examples. Again, not keywords. These are the two methods that we actually created, so write log and read log. And so we're walking through those. We're going to hit the write log first, and then we're going to read log and print that information out. I actually have one already, so I've run this before, so I'm going to delete that so you guys can actually see it get created. And we'll go from there. So this is example2.py. So we get our prompt as we expected. I'm going to put in my name. It's adding a new log entry to my file. If the file doesn't exist, that dash there, the A, what append does is it creates a new file for us if the file doesn't exist. If I want to run it again, I can put in, let's do Carlo since he was our host today, and then I'll see two entries there, and actually can see that file created within the directory that I ran that. So that information is now available to us here. So pretty straightforward reading and writing to files within Python. Could be of particular interest to those that are dealing with device level configurations. So our exports from show config, if we wanted to update those things across multiple devices, those are flat text files, and so you might want to get into a situation where you are reading and writing from those flat text files. Let's jump in and see what we have as far as questions are concerned. Is this code example compatible with Python 3? Yes, we are running this all in Python 3. I was asked to explain the width once again, please. Yes. So you won't see this a lot within Python code, but it is useful, especially when working with files, pun intended. So the width directive is allowing us to define the file that we are going to be working with, the state that it's in, so the working state. So if it's append or read, I think there's a write to, I'm not 100% sure of that, and then give us a way to interact with that object. And then anything within that, and we notice that anything under there is indented. If I were to remove this indentation, it would cause an error. So it is telling me that within this structure, I can interact with that file F in a certain way. And when that code is done, it will then close that file for me and release it from memory. So I don't have to worry about specifically doing the open and close methodology that you might see with other interactions with files. So with allows us to open and close that file with very minimal code. Let's see, let's answer one more question while we're here. Actually, someone called me out on the functions comment, so I apologize again for that. Alrighty, jumping forward, I will, if I don't get to your questions as part of this discussion, I will attempt to answer them through, I think we're doing them through the video messages, so I will try and get to all of them over the course of the next couple of days. So moving forward, we have our example 2.py that we just walked through. Oops, and now we're getting into example 3. We're going to quickly talk about dictionaries, lists, and working through those data structures and loops, and specifically conditional statements. So let's pop that file open. So the thing that you need to keep in mind as you're dealing with data structures within Python is that very simply, a dictionary will have curly brackets, a list will have square brackets, and you connect them. So in this instance, we have author, and each of those situations in a dictionary has a name-value pair. So we have author and then color and shape, and those tie to particular names and then values tied to them. Lists tend to have only tend to be, they don't need to specifically be that, but homogeneous values. So when we're talking about colors, it's always going to be colors. You're not going to see blue, green, red, and then the number 1 in a list, although you could. From a best practices standpoint, we tend to keep those homogeneous. And then you can have a list of dictionaries. And this is actually very helpful to talk about because a lot of the content that we're going to get back from our API calls that we spoke about in the last session will come back in JSON format. And JSON format is basically, it tends to be a collection of dictionary values. And so there is a distinct connection between JSON and dictionaries within Python. And it actually makes it very easy to parse that data whenever you're working with REST APIs. And we'll actually see how we parse this information as we come out of here. So we have our examples of a dictionary, our example of a list, and then our list of dictionaries. And then here's our entry point for the function. So again, this is delineating from any other libraries that I'm pulling in that this is the actual portion of the application that I want to start with. The first thing we're going to do is print out the author's name. That's going to reference the author dictionary. So if we go up and look at the author, we only have one author, and so we're going to pull its name out. Same thing for the color. We're going to then print out our colors. And I know these seem like pretty simple examples, but these are very powerful structures within Python. You'll notice that, and again, if you're familiar with other programming languages, you don't have to build out iterators to go through the array index. And so an array and a list, or the list index, are the same thing. So we have a list or an array are the same thing. They're just lists of items. The lists themselves have inherent indexes to them, and they're all 0 offset. So if we wanted to access color 0, it would give us back blue. If we wanted to access colors 1, it would give us green, and colors 2 would give us red. If we want to loop through all of them, though, we don't have to generate our own index counter. We just need to call out individual items within that list. And we can name that whatever we want, but for sake of readability, we tend to name our lists with the plural, and then within that one, the singular. So for color in colors, we're going to print color, and it'll go through and print our colors for us on each line. Then we're going to ask for a new color and apply it to check it against our author's color. So we're going to ask for user input, our keyword input here. What is your favorite color? If that new color is equal to the author's color, so we're accessing that author's color, then we'll print out a message that says you have the same favorite as. If not, and that new color is not in color, so we can check the whole array with this one line. We don't have to loop through and check each individual value. Again, a real nicety in this language that you don't always see in other languages. And then that's a new color. We're going to add that to the list. And there's a function that's part of the colors, or that's part of the list object value that allows us to append the new color. Again, and if you were to look up the list methods available to us in the Python documentation, it would tell you that you have append. So it will add in that new color to the list and then print those out. Or print out the message that we've added that color. And it's actually adding it to the end there. So in this instance, we have 0, 1, 2. We know how long this colors list is, and now we're going to actually print out the last list. So colors 3 is the one that we've added on. Else pass, and that'll basically kill our script. So the end is it's basically a blank. If you're not doing anything in the else, then pass. So let's run that one. So we'll say my favorite color is fuchsia. It's a new color, added to the list. There are now 4 colors in the list. You've added fuchsia. Now, because I wrote that all in memory, if I were to do this again, it's still going to give me just the basic green one, or basic ones that were already there, blue, green, red. I didn't update any files or anything like that. So that's working with dictionaries, lists, and a very simple example of working with dictionaries, lists, and lists of dictionaries. Now, that being said, we will take a look more tightly at these data structures next week as we start to deal with actual network programmability type data. So if you're like, hey, colors and names are nice, can we actually see a gigabit Ethernet configuration? That'll be next week. All right, so we have example 3 there. Let's make sure we're all in line. A note on conditional statements. So conditional statements are anything basically that starts with an if. In this instance, when we're actually comparing a new color to the author's color, we're using the equals sign. That's comparison. So equals is assignment, equals is comparison. And then we have keywords available to us like not in, and that allows us to evaluate the whole array or the whole list without looping through it. So there are some pretty cool things available to us. We also have if new color in colors that will allow us to evaluate the array in the positive. So you don't have to go through and generate a for loop to evaluate each individual item. Python is powerful enough to do that for us, and answer those later. So we're looking for plus equals. What does plus equals mean? Did we see that in our code? Let me check that again. So plus equals means, that's an excellent question. I did skim over this. So this particular operator, plus equals, is the same as doing this. Equals message plus. So what you were doing is concatenating strings Whenever you have a string, so in this instance we have message, setting it equal to there, now, however many colors in the list, and then we're concatenating that string with the color you added was. So plus equals is going to concatenate those things. You can also do this for iterators for numbers. So if you have a value that is I equals 1, and you want to iterate it, you can either do I equals I plus 1 or I plus equals 1. And so that's what that means as well. So it's just a shorthand way of doing the above. Okay, so that was an excellent question. And we'll answer one more. Let's see here. There was the Timothy asked, why are you using static reference for the list 3? Is there a list method that returns the reference of the last item in the list? Yes, I think it's length. So right here we indicated that we have colors sub 3. I think, let's give it a go. We're going to do this on the fly. We'll do len, oh yeah, we have len subcolors plus 1. Actually, len subcolors will give me the end. No, plus 1. Subcolors minus 1. Okay, so the question was, why did I reference the, statically reference the end of the end of the list? Because I had 0, 1, 2, 3 was the color I added. Dynamically, you can reference it by accessing the length of the particular array, and then you want to do it minus 1 because it's 0 indexed. So this is the way to get that last one. So this should work, unless I'm having another brain dump like I had before. Oh, not colors minus 1. It's len colors minus 1. There we go. Another quick lesson that we have here. Whenever you're running Python, there's what's called a traceback, and it'll tell you where your error is. And basically what this said to me is you're subtracting a number from an array, and you can't do that. So there we go. So now I've dynamically accessed the last value in the list. So by referencing the length function that is part of Python. Again, aqua blue, so that is a keyword available to us. Okay, answered a couple questions. Let's jump back into it. We're running out of time. You can access Python interactively. This is a pretty powerful tool when you're in the middle of writing code. And let me make sure I'm in the right directory for this. Let's go to Python part 2. You can access the interpreter by simply doing Python 3, and that'll open up the interpreter to you, or Python, if Python 3 is the only instance you have running. Now I'm in the Python interpreter, Python 365 interpreter, and I can actually write lines of code in here and see how they're evaluated on the fly. So I did have so we can do something like import pieces of libraries. This is a library called pprint. It is it allows you to format your printouts a little more cleanly. And then if I want to do pprint hello world, I can do that. And it'll print that out. Now you might be asking yourself, why is this particular instance useful? One time that I found it particularly useful was I was evaluating a string. I needed to perform a regular expression activity on a string, and the way that I was doing it, where that application was running, it was a bot that was running on a server, and that bot was responding to prompts, and I had to make sure that the prompts were being parsed properly. And so every time I, did this evaluation of the string, I would push the application to the server, try the bot, wouldn't work, pull it back, change the code. It was an arduous process, and every time I made a mistake, I'd have to, take 5 or 10 minutes to get that bot up and running again. Well, then I realized, hey, I can evaluate inputs into the string evaluation in my interpreter. So I was able to create variables on the fly here and pop them into the function that I was creating that was doing the evaluation and see what the output would be rather than pushing that code every time or even running it locally. It saved me from some headaches in there. So it's a good tool for building out some trickier lines of code that you're not exactly sure how they're going to play out. So it's a good kind of trial and error tool available to us. We can also hit up scripts within our particular examples as well. Let's see here. If we look at our doubler function, let's see here. We're going to exit. Let's do Python -3-I, and then example 1.py. And that'll evaluate it in our within our interpreter, and then I can even do doubler 52. And now all of the functions that are available to me in example 1 are now available to me in my command line. So if you're building out some pretty, if you want to test out those functions, like I'd mentioned, adding in different values, you can do that with the Python interpreter as well. And so this -I directive keeps you from running the script the way we had been running them before, but then runs them in the interpreter. Let's see here. We can also do some other fun things like working on our date time. Alrighty. Just going to copy and paste these things in. Date now is not defined. Oh, I had an error in there. So we imported from date time with us here. I put in the wrong function or in a error here. So it's date now equals date time dash now or dot now. And then we can actually look at the string for the date time now. And it'll give us our value there. We also have the ability to look at functions available to us through the dir value. So because I had imported example 1, we have doubler available to us, and so this gives us the ability to access that function. If we wanted to access date time, the specific variable that's available to us, dir gives us that kind of functionality. Do libraries really quickly. Oh, we talked about libraries already initially, but there are a couple of different ways you can generate libraries. You can also import them. You can create your own libraries. And so in our example here, we've created a library common vars. And we're importing the shapes value as part of that. And if we look at the code for that, we have Python part 2, common vars, and that's going to import our list of shapes. So now those lists of shapes are available to us, but we don't have to define them specifically in our example. So as we do from common vars import shapes, we can do that. And then we can also import other libraries that are native to Python Or, and then this is the third way, is to do a pip install from the Python package index. So there'll be instances where we run into a scenario where you'll have code and you go to run it and it'll say no module blank found. And that's because the reference for that particular library has not been installed on your Python instance. And so we have the package index available as well. Let's see here, see if we have any good examples of that. You can also wrap up a bunch of different dependencies within the requirements.txt file. When you do that, you do pip install -r requirements.txt, and that will allow us to go through and install all of these dependencies as we see fit. And we'll get into that a little bit more next week when we talk about that, or when we talk about the data structures and the packages available to us to deal with device-level interfaces. Specifically, the one that we're looking at here is NC Client. And the last thing that I did want to cover is our virtual environments. We don't have time to fully get into them now, but I do want to just touch on them so you're aware of them. So virtual environments are the ability to run multiple instances of Python on the same machine without one stepping on the other. So a lot of different applications have different dependencies as far as the libraries that are installed. And so it is good practice to run those separate projects within a virtual environment. So for example, I'm going to show you real quickly how that would work. Say, for example, I have a project that requires Python 2. I can create a virtual environment called Python 2 project. And set that Python version value to Python. Now it'll create my project, it'll set that Python version to 2, and if I, let's see here, Python 2 project. If I create that virtual environment, now my command line tells me that I'm in that virtual environment, so I can now run any projects within it. If I do Python -- version, it'll tell me that I'm now running Python 2.7.1.4. Now, if I get out of that, deactivate, and I create another project where sorry about that, where I want to use Python 3 instead of Python 2, and I activate that, one second. So what I'm doing is creating another project that's using Python 3. So let me make sure that I activate the right one. So I'm in that project now. We see a different command line show up for that particular project. And then when I do a Python -- version on that, it tells me now I'm using Python 3.6.5. So you can see how, or you have different dependencies, and that's really the biggest thing are the dependencies. So you need different versions of the requests library to make API calls. You can delineate those between projects. So I apologize we didn't have to go through that a little bit fast, but that's kind of a tool in your tool belt that will allow you to work on different projects pretty relatively quickly. And I just showed you how to set that up. We talked about pretty print for some foundational libraries. Sys allows us to access our arguments online on the command line. Those are pretty useful for when you're kicking off services that require some kind of input into them. Operating system interfaces might allow you to access environment variables, and then we saw how date time is being used as well. I would highly recommend heading to, let me share with you guys the link to the code samples here, and then the video series real quickly, and then I'll let you go. So all of the code from this is in GitHub at Cisco DevNet/Net Programming Basics. So you can grab that there. I'll put that in the chat window. And then the network programmability series, video series that covers what I covered today and then expands upon them is at this location here. So if you need to re-review what we've done or want to get your hands a little bit dirtier, those are two great links to access the content, the intro content today. So as we're looking at this, this would be the introduction, the programming fundamentals, and then we're going to start looking at some of the device APIs as we look at the data models going forward. So I appreciate the time. We will attempt to answer all of the questions. I saw a lot of them coming in, and we'll attempt to answer them as part of the video post, or the video posting of this particular course. And why that's important. So let's take a look at that. We're going to do a quick intro. We're going to take a look at manipulating XML in Python, working with JSON in Python, and then dealing with YAML and CSV. All of these have similar ways that we would deal with them, but little nuances here and there, so that's why we're going to call those out. And then we're going to show some real-world examples, leveraging REST, dealing with JSON in a REST request, working with NC client and XML, and then working with our CLI with NetMiko. And then we'll close up shop and hopefully answer any questions that might be outstanding. So let's talk about XML first. This is generally put out there as a human-readable data structure. There is a lot of overhead to it. As you can see, each particular line item has a tag there. So if we look at the right side of our screen as we're looking at it, we have the name for the particular IETF interface for this particular example. We're looking at a description of interfaces from a router. Name has a open tag and a closed tag. We're able to nest information within our particular data structure as well. So if we're looking particularly at our address settings for IPv4, we have our IP address and our net mask tied to that. If we had an IPv6 address, we would encapsulate that in its own content as well. So XML is used to store, transfer, and read data. It was designed for the internet, and so it was created specifically to be passed over HTTP. It has some of its underpinnings in HTML, but as you know, HTML has very specific tags that are defined for it. The tags for a specific XML document are identified in its namespace or schema, and so the data definition in this particular instance where we have an example of an interface coming from a router, the tags or attributes of name, description, enabled, IPv4, the address nested within the IPv4, that's all part of that namespace, that XML NS at the top of the diagram there that says IETF interfaces. So there's an expectation on that on the side of the application, or on the service side, the router itself that's providing that information, and there's an understanding then on the consuming application side that allows it to collect that information. As we note, tags surround those elements for structure and layout, and the keys, and keep in mind this key value representation, because we're going to talk about that when we look at some of our other data structures. The keys are the actual tags themselves, so that name for gigabit Ethernet 2, that value, the key is the name, and then the value is gigabit Ethernet 2. And it should be noted that white space is not significant. I did see a question pop up. So that was just a comment. Hello, Sergio. Let's move on. So an XML object is a related tags, a related set of data surrounded by tags, a related set of data. Objects can contain other objects or data entries. So when we're referencing things like objects within XML, this IPv4 is a good example of an object. We have an IPv4 object, and within that it has an address object, and it has attributes IP and netmask. And so we could have multiple addresses managed within this IPv4 object. All of this is encapsulated in the interface object. So at the top level we have interface, and we see that closed off by the interface. So everything is within the scope of its opening tag and its closing tag. And just like we do with attributes, objects are identified by those key value pairs. Lists can be contained within those as well. So as I noted before, we could have a list of addresses that are tied to that particular interface. And so repeated instances of that will be listed out with the same tag. And so when we're looking at the addresses list, we will have the initial IP address and netmask offset with a closing tag. We also have addresses, a second entry for 172.16.0.3, and then we have a third entry for 172.16.0.4. So we're able to leverage this data structure to show the containment of items within a list or an array, however you want to call it. And that is how they are represented in XML. And so how do we work with that? And we'll actually jump into some code. So let me share that real quick here. What we are looking at is code that is taking in a XML example. And our XML example is what we were actually looking at before. Let me make it a little bit bigger so you guys can see here, and I'll highlight some of the things that we called off in there. We have the XML version, the particular encoding that we want to use. We have the interface, and this is our parent object, and that's closed at the bottom here at /interface. The XML namespace is IETF interfaces, so this is where the definition of our data is coming from. So that defines the fact that we have a name, that we have a description, if that interface is enabled or not, and then it's address space. And so then we see our address object. So this is a valid and working set of data. We do have it statically written into a file here, but we're going to see a dynamic example a little bit later when we get through all of our data structures. So keep this in mind. So working with those in Python, most of what we'll be doing when we get into things about network programmability or even interacting with APIs in general is dealing with data structures. Now, we introduced XML because it's something that people are comfortable with, and it's something that people know and they've heard of before. But when we move to JSON, and I'll talk a little bit more about JSON and compare them to XML, there are instances where you may have to interact with XML data in Python, and it's actually very easy to work with it. So there is a library that is supported by the Python organization called XML2Dict, and what that's referencing is the ability to convert XML formatted data into a dictionary format that Python understands. Now, we may have talked about this before, but if we haven't, data structures within Python contain lists and dictionaries for today's examples, and those are the two most common ones that you'll see. There are other data structures within Python, but we won't get too down into the weeds with those because the two you need to worry about today are dictionaries and lists. Dictionaries help define objects, and so when we look at this example, at our XML example here, what we're doing is we want to convert the object of XML, or the XML object that's identifying this interface, to a format that Python is comfortable with managing. If it just pulled in the raw XML, we could work with that in theory, but it would only understand that as strings, and working with strings can be particularly daunting in any programming language. And so looping through and finding substrings within a particular device isn't very efficient. It's not good code practice. And as we'll see in a second, being able to convert that data into a dictionary value opens up a world of possibilities with being able to parse that information. So we're using this library import to dictionary, and what we're going to do is open up that XML example file and just read it in raw and then print that out. What we will see is that, well, actually let's run it and then we'll jump back and forth here. So let me share my terminal. And blow that up. 1 second here. So I'm going to be running the XML example, and all of this content is available to us. I will post the links at the end for where these code examples are located, and I believe the slides will be provided as part of the link for this particular service. So we have XML to dictionary example. And the first thing that we see is a printout of our raw XML example file, okay? And the thing that we've added in is quotes around each line and a \n that tells me that basically what Python has done is read this in as a series, actually as a long string, and it concatenated all of those lines together. So to parse this information out without converting it would take a little bit of work. But I'm capable then of using this XML to dict library and parse that XML example out and save that into a dictionary object within Python. So that's what this line is doing. There is a method within the XML to dictionary library that's called parse. And what that does is it takes raw XML, and since XML is a well understood data format, the coding for this allows us to convert it to a dictionary because it supports dictionary, the dictionary data structure, converts it to an XML to dict, and it prints that out, that value out. And what that then gives us, as we go back to our terminal, is what's called an ordered dictionary, and it provides us with the ability then to parse information out of that. It's the same data, it's just now in a structure that Python can understand a little better than the string that it read in initially from XML. And what it does, and what you'll notice, is that it tends to look a little bit like JSON, but instead of curly brackets, it's using parentheses. So in each instance, though, we still have a name-value pair. It just looks a little different than it did in the XML. So for Gigabit Ethernet 2, for the name, we see name here, Gigabit Ethernet 2. It's all the same data, description, wide area network, if it's enabled or not. And now Python is able to work with this particular example and parse information specifically out of that. So if we go back to our code, we can now very easily, in one line of code, XML reference the XML underscore dictionary that we created and pull out the interface name and then print that. So if we look at our example, we're looking for the interface name. We expect that our return value will be gigabit Ethernet 2. If we look at the code, we're setting that name equal to that value and printing out that name. We can also unparse that dictionary if we needed to actually send XML data back to our service, and there's a value called unparse in there, and then we print it out. So let's look at the result set for that code. Let's actually do this and run it again. I'm getting so we can see what it looks like here. 1 second, my terminal has There we go. Let's run this again and I can show you guys what's going on. So we have gigabit Ethernet 2, that's where we parsed out the name value in that particular line of code here. So if we look at XML underscore dictionary, the converted value, and then we're pulling out interface name, so we're able to hit that multifaceted or multi-tiered array and pull out that particular value, and then we reconverted it back into our string. It didn't put all of the spaces and stuff that we did before, because once you converted it to an ordered dictionary, it pulls out the white space. So this is valid XML, just like this is valid XML. It's just that when we reconverted it, the application didn't know to put in, for example, these spaces here, because in XML, a white space doesn't matter. So that's our example for XML to dictionary. I will check very quickly to see if there are any questions in the Q&A to help with help your understanding. Omar asks, currently, does XML replace by JSON? It depends on the service. We're going to get to JSON in a second, and I'll explain the differences and why JSON is becoming more and more prevalent. And Matt already answered if this is recorded for later viewing. So thank you for the question, Omar. Our presentation here. We're going to break down JSON. JSON stands for JavaScript Object Notation. Do not get bogged down in the fact that it is tied to the notion of JavaScript. It came out of a data structure set that JavaScript was comfortable working with, but in and of itself, it is not necessarily tied to JavaScript, so you don't need to write JavaScript code to just use JSON. It is actually a pretty popular data structure now, a data format, and most of the REST APIs that you will encounter going forward will be in JavaScript or object notation or JSON. It is comparable to XML. You'll notice that there's not as much overhead to it. It tends to be a little cleaner and easier to read, in my opinion. Some things that you need to do or to understand as far as looking at JSON, the biggest things, the things that you need to download as part of this session, if you learn nothing else going forward, is that JSON objects are noted with curly brackets, and lists or arrays are offset by square brackets. So anything that has a curly bracket around it is considered an object. So just like with our XML service, we noticed that IETF interface's interface was the object that everything else that is housed in. There are attributes that are tied to that object. There are name, description, enabled, the IETF IP address names, and then there's a potential list of addresses that could be tied to that as well. So just like we saw in the XML, we were able to list out the addresses. In this particular instance, there's only one, but now I know that within this particular data definition that I could have multiple that are residing within this address space because it is offset with square brackets. Everything else is an object. Or an attribute. So IETF interface is an object. Name, description, enabled is an attribute. IETF-IP with IPv4 is a object, and then within that we have an array or a list of addresses, and within those addresses, each one of those is an object. And then we close all of those up here. Now, the challenge sometimes when you're dealing with curly bracket and square bracket notation versus what we saw with XML is that we don't know. I mean, this one's really easy because the object itself is short, but there could be objects that have dozens, if not hundreds of lines of attributes that are tied to them. And potentially we could run into a situation where we don't know, while we're looking at it, where these square brackets go. That being said, a lot of times you're going to be using these things within code, and you don't necessarily have to worry about what it looks like when you're reading it. So keep that in mind. Sorry, we went forward a little bit too fast there. White space in and of itself is also not significant, as we saw with XML, so keep that in mind as well. A little bit of a difference between JSON and XML as well is that key is our first item on the left within the pair, and then the value is on the right. So if we're looking at this particular example, the name is the key and the value is gigabit Ethernet 2. I think that's all I had there. Strings, it's not called out here specifically, but strings are always noted with quotes. We did not see that happen in XML. Numeric values are treated without quotation marks, and Boolean values are treated without quotation marks as well. As we see, our value of true does not have quotes around it. I also talked about objects. One other thing, there's no comma at the end, so keep that in mind. Attributes are offset each time by commas. So if we're looking at this example, on the far right of each line of an attribute, we have commas because those attributes are all part of the IETF interfaces :interface object. That being said, if there are lists of objects within a particular array, you will see commas after them. So that's be aware that there's a little nuance between that. So for our address list, we have the actual addresses objects. So we have the IP and netmask attributes as part of that. But if we had multiple in that list, we would see a comma and then a new entry for the object and a new IP address and a new netmask. So keep that in mind as you're taking a look at the JSON objects. And here we go. Here's an example of that within there. These are comma separated, each one. And so we can identify those as objects that are listed as part of that list addresses. So just like we saw with the XML, we have an IP address for .0, .2, .0.3, and .0.4. The netmasks are all the same, but those attributes are specific to each individual object in that list. And again, they're notated with square brackets. And then again, within there, I cannot stress this enough, curly brackets offset objects, square brackets offset or note arrays. So back to the code. What does this actually look like in the code? So we have our JSON example. This is just what we saw before. And actually, we could have another address in here. And we'll copy that and just for sake of understanding. One other thing to note about JSON, you will see instances where the top level of a particular response in a particular API call might offset things with a square bracket or a curly bracket, and then everything is rolled into that parent object. And that might not have any name tied to it, and this one is in that instance where there's no name tied to that parent object. You might also see instances where if there's a list of items and they don't really want to tie it to a parent object, you could see Java or JSON data formatted that's valid that's offset with a square bracket at the beginning too. So the documentation for a particular API or data set will tell you how that data format is structured. It'll provide you with a schema and a data model, and then it'll give you a few examples to work with so that you know how to parse that data when it's coming back. This one in particular is offset as an object, so once I save it, I'll be able to convert it to JSON and work with it or convert it to a dictionary object within Python and work with it there. So here's our code example. We're now using a library called JSON, and there are a number of methods available to us to manipulate JSON data that's coming into that Python application. All we're doing is reading that file in, and we'll see, just like we saw with the XML example, that we're going to see that data come back as a string. And so we need to convert that string into a dictionary object, and that's done by this JSON.loads. And it's going to take that JSON example string, convert it to a dictionary object that we're going to call JSON_Python. We'll print that out just so you guys can see what that looks like. And then, just like we saw with XML example, is we're going to pull out the interface name with one line of code. So this line of code here is the exact same as our XML example here. So we just named those interfaces differently though. So same kind of data coming back, and we're going to print that out, and then JSON.dumps reconverts it back to that string value. So if there is a scenario where you're sending JSON to a service, you might need to reconvert that back to a string so it understands that data structure coming back, because Python has added things to the dictionary value, so you can't just send it right back to the service. So that's what we're looking at here. Let's run that and see what the result is. So we saw our string get printed out. So similar to what we saw with XML, each end line has a \n converted to it, just like we would see if we showed the text codes within our particular JSON example file. Then we print out the conversion of the string to our Python object, our Python dictionary, so that we can then parse that information. This is not providing us with an ordered dictionary. An ordered dictionary would sort these based on the keys, but JSON.loads doesn't do that. It just converts the data as it comes in and allows us to grab the name of the particular interface that we're looking at. So that's where this line comes in. So that's how we're able to pull Gigabit Ethernet 2 out of there. And if we're looking at the code for that, it's just a parsing of the file, or of the data structure as it's coming back. So IETF interfaces, :interface, and then the name. So if we look at the output, we have IETF interfaces, interface. Don't care about description, not pulling that out, skipping it. Enabled, skipping it. IETF IP, skipping it. Oh, here's the name. What's the value for that? Gigabit Ethernet 2. All right, great. And then we reconverted it back. This is valid JSON, but now it's taken out all the white space, basically, that we had put in there. So again, that ties to that notion that white space is not a big deal in JSON or XML. It's just added in for human-readable structure. It's not something that you necessarily need to have for the computer applications to work. So that's our JSON example. We'll check the questions real quick here to see if there's any Q&A out there. From which version of iOS can we pull the data in form of XML or JSON? I don't know that for sure. I know that the versions before 16 support what an interface we're going to talk about in a minute called netconf, using NC Client, and NC Client generates XML, and I'll dig into that a little bit more. Anything that supports REST comps going forward will be JSON, so it just depends on how you are able to connect that device. So good question, Jagadish. And then the second question, can the double quotes in JSON be replaced with single quotes? Yes, they can. Snarkily, to show the same kind of data, and let's actually jump to our slides to talk about it. So we got JSON, simplifying YAML. Same things. That's funny. It says yet another markup language, but it ain't markup language. missing some key components to being a markup language. But it is relatively useful for talking about networking components. It is very minimalist. You'll see there's no extraneous curly brackets or square brackets or tag names. We've now stripped all of that out. We don't even have quotation marks around things to define these things. So it is relatively readable. It's not a mishmash. In this instance, whitespace does define structure. So whitespace indentation does define structure, as we learned about in dealing with Python. Python in and of itself only deals with indentation to define its scope. So again, looking at the same set of data that's being represented before, we have our IETF interface, our name, description enabled, and that's under these four things are underneath that IETF interfaces. So I know that they all belong to that definition, to that parent. And then within the address space, we have the same thing where the address is being is a child of IETF, IP, IPv4, and then lists are offset by dashes. So when we get to our list of addresses, we'll have address dash IPNetmask, dash IPNetmask, dash IPNetmask. Key value representation is key, no quotes, and then value, again, no quotes. So strings are not surrounded by quotes. As we noted before, the related set of data is at the common indentation level under that name, so reinforcing that. An object can contain other objects or data entries, just like our other data structures. If it didn't, it would be useless, and we wouldn't use these things. So anything that XML and JSON can show, YAML can show as well. Here's our list of data as examples. So each IP address has a dash assigned to it. It's very minimalist. As you can see, we don't have the word addresses over and over again. We don't have extra brackets. We don't have commas. It's just each line in a row. And yes, Python can do that too. And actually, in a very similar manner that we saw with Python, or with JSON. And so here's our example data. And let's actually add another IP entry. For fun. So within our YAML example, we're going to import a library called YAML. So if there's something that you want Python to do, there's likely a library for it. So there's one that already exists for YAML. We're going to read in that YAML example just like we did with JSON and XML. We're going to print it out. And I bet you can guess what that's going to look like. We're then going to use a method within the YAML library called .load. That'll convert our YAML example, our YAML string, into a Python dictionary that it knows how to work with. Once it does that, we'll then parse out, and you guys can see a pattern here. We're going to parse out the interface name and print that out. And then again, like we did with JSON, we're going to reconvert that back into that string should we need to push that back up to the service. So let's see an example of what that looks like. Oh, that's not good. I probably did something wrong in setting that up. Indentation was wrong on this file. It did not like when it went to convert that. So 1 second. Dealing with computers, got to make sure everything's right. All right, so we see our file being read in as a string, as we expected. We see the conversion, and now it looks almost, actually it looks exactly like it did when we converted the JSON to our Python dictionary format. And now we're able to parse our name out just like we expected. And now, because white space matters, when we converted it back, it actually made it look exactly like we needed it to for our string value. So it looks very similar to what we have up there. The one thing that I don't know, and I will have a mea culpa because I don't know why it added in the curly bracket around the object unless that's some notation that you can use for that. So I will claim ignorance on that particular instance where the curly brackets are there. If someone knows, feel free to share that in the chat area. So that's our YAML example. Now, we'll do CSV really quickly because you might run into instances where you are working with comma-separated value files or some other delimited value file, and it's helpful to know that Python can handle those things. So there are, just like with YAML and JSON and XML, there are libraries out there that allow us to work with this. They are not as they're not as functional as the other libraries because CSV is kind of a loose file definition, whereas JSON and YAML and XML all have very strict requirements that they have to tie to, whereas CSV, you're defining the data and then you're building it out. So it leaves a little bit of leeway there for how we can work with it. So what we're actually going to do is open the CSV example file and then read that into a, the CSV reader will read that into an array, and then we're able to parse that array and print that out. So our example that we're looking at here is we have a list of routers and their locations and IP addresses, and we're going to read those out and talk about which router we're talking about, where it's located, and then its IP address. So it's going to hit each part of that array, and then it's adding it to each row is then parsed out as part of that array. So you can think of it each time that this loop runs for row in CSV Python, it's going to create an array that parses out each individual value of that comma-separated structure, okay? And then print those out. So a pretty simple example here. And we'll run it. And it just creates the string that we generated. So not a super exciting example, but something that shows you that it can be done. All right, we'll open it up for quick questions if there are any. The question, could you please tell which data format representation is standard and is most common today, e.g. for its popularity or ease in deployment or even ease in coding for the network programming field, XML, JSON, or YAML? That's actually kind of a loaded question. So as we talk about network programmability, you're going to be starting to take a look at REST APIs that will be leveraging JSON, and you will also see more and more devices supporting REST-conf, which is the ability to interact with the configuration interface of a device through a REST method rather than connecting to the CLI or going through netconf. That being said, the command line will leverage everything in YAML, and the XML will come through in netconf. So netconf supports XML, not REST or not JSON. So you might run into situations where you're dealing with all three. JSON is becoming more and more popular, and for that fact, it is becoming easier to use and building applications to that aspect because that's the adoption is larger. The other thing with JSON is that it ties more closely with Python dictionaries. So as part of tying this to a programming language, which really doesn't need to happen because JSON and REST are programming language agnostic, but you can see it's very easy to parse JSON data as part of a Python application. So that question is very good. It's loaded. If I was getting into network programmability, I would become familiar with all three of them, just to be comfortable with any interface that I then run into. If I'm dealing with an interface that's netconf based and it's not running iOS that supports JSON, then or supports RESTconf, then I will then I'll need to know the XML or know how to deal with XML. And then the other question tied to this: what are the use cases of all three data structures? So YAML does seem to be more simple. It depends, again, on the interface. There are interfaces that you're capable of. YAML is going to come back in a CLI type interaction, but that's not always as dependable as what you can get through netconf or RESTconf. So again, it's just a matter of the devices that you're working with and what they support. And that being said, so that's device level interaction. So that's one controller, that's one router, that's one switch that you're interacting with. As we move up the stack, there are starting to be deployed what are called network controllers, things like DNA Center, where it's providing us REST-based APIs, and those interfaces into those devices we might not even be interacting with. It just depends on how the network is set up, how much money you spend, those kinds of things will come into play. And in those instances where you're interacting with a controller's API, and you saw this before with APIC EM if you had worked with that application policy infrastructure controller, or ACI, application-centric infrastructure, all of those things are software layers sitting on top of the network. It's interacting with those network devices either through SNMP or NetConf or RESTconf potentially on those network devices, but then your potential script, your potential application, your potential web service would be interacting with that controller's REST API, and that data will be coming back in JSON. So understanding that there are differences and nuances between all three, understanding that there are differences, and then how you can work with them is probably the most valuable thing. It's always better to be multifaceted in any instance, and so being able to understand XML, understand JSON, understand YAML, and not just focus on one or the other, allows you to build out some more dynamic and interesting applications and makes you more viable within the marketplace as well. So those are some great questions that came out of there. I do want to show you some real-world examples of how these would exist, and let's actually connect and make some API calls. I did want to point out, I did import and install all of these in my Python environment. I know we talked about this when we did the Python class, but for those who were not there, there's a method called pip install as part of Python, and it is able to go out and get our different libraries that we wanted to work with. The only one that we needed to add in was XML2Dict. YAML, JSON, and CSV are all native in Python, so we don't have to install those separately. But this is our list of libraries that we've added in. We're also going to, I take that back, PyYAML was installed as well. So XML2Dict and PyYAML. JSON is the native. JSON and CSV are the native ones. We're going to see NC client and requests in action in a second. I'm going to try and get the NetMiko example to work, but I need to find the right sandbox environment, and that might not happen. So I'll talk about the code, and then and we'll see if we can get it to work if you guys can sit by. But first we're going to talk about requests, and that is going to be leveraging our HTTP calls to our REST services, to our REST APIs. If you attended the first of these courses, we did an introduction to REST APIs and what that meant. So what we're going to be doing is calling an HTTP endpoint. So in particular, we're going to be sending a request to our iOS XE always on sandbox. So it's at address ios-xe-mgmt.cisco.com. We're going to hit port 9443 because that's our RESTconf port for that particular service. and it uses what's called basic authorization, and I'm going to send it a username and a password as part of the API call. I will be requesting my data back in, sorry about that, in yang-data plus JSON. So it's basically taking the Yang model. So Yang and YAML are kind of tied closely together. That's the data definition for our network or our device configuration. I want it then formatted in JSON, so that's where this header is coming from. And then I'm going to make I'm going to create my URL. So it's HTTPS in this instance, my IP address, my port, and then the endpoint is tied to the Yang data model. And I know we didn't talk about Yang data models. That could be a whole other class in and of itself. But suffice to say, there is this thing called a Yang data model, and it defines the configuration of a particular device. Within that, it tells us that for the RESTconf interface, I can access the interface name or for a particular interface by going to RESTconf data interfaces and then setting the particular interface name to get the information for that particular interface. So this data structure, or I'm sorry, this URL structure is defined by the Yang model for this particular router service. We're going to create our URL, so we put in the router IP, router port, and then I'm making the request. So this is our library that we're importing in. It's called requests, and we install that in our Python installation through our requirements list. So this is where request is, API_requests, we're going to import the request library, and then it has a method in it called get. So requests allows us to make HTTP calls using the commonly known HTTP or commonly supported HTTP methods of get, post, put, delete. Those are the ones that you're going to see most often. Get will probably be the one you see all the time because we're getting data from our particular service. In this instance, it's a running router's configuration. We're going to pass in the URL. That's where we set up here, U. We're going to send our headers. And then there's a method within there that allows us to send auth. And so we're going to send in our username and password. And this is going to do the heavy lifting for us to create our base64 encoded string that allows us to support the basic authorization method. So we had talked about that when making API calls as well. So the code does it for us. We don't have to do any encoding. And then this line in here, this verify false, it's basically saying if there's no valid SSL certificate, don't worry about it. Again, this is just for example purposes, so don't necessarily look into that. You're going to want all of your services in production to have some SSL certificate applied to it. So this is just so we don't get errors on the API call. We're going to print out the response. So it's going to make this call, and it'll dump the result from this API call into a variable R, and that variable now has what's called a response object. And there are different attributes that are tied to it. We could pull out the headers, we could pull out the status code if it was 200 OK, or if we weren't authorized, it would give us a 401 unauthorized. It makes that call, and then we can access the body of the response in .text. So this is the meat. This is everything was good, and we got the data back that we asked for. We got the interface information back for Gigabit Ethernet 1. So we're going to print that out. We're going to convert that to JSON. Save that as the API data variable, and then parse out our, this one is now, they've changed it. The latest one is Cisco iOS XE interfaces .oper interface, and then the names there. So the data structure and definition will tell you how to parse that data out. And then we're going to print that interface name. So let's actually see that in action. Now, this is going to take a little bit longer because we are actually making a call to another service, and I actually think that service is running in Ireland. So I'm in Cleveland, Ohio in the United States. So for those of you who are outside the United States, hello. And I will be making a jump to Ireland and then coming back. So let's do this one. API request example.py. So I did really quickly want to show you what happened here. I didn't tell it to turn off the warnings, but it is telling me that I don't have a valid certificate for that particular service. So I did get a warning saying, hey, you shouldn't be doing this, but we're going to do it anyway. So insecure request warning. But we get back our data, and we see that it's structured in that string format that we saw when we were looking at the sample examples that we were looking at. But we have the interface, the name, type. We see a lot more data now because this is coming from a live service. And let's see here. So we wanted to pull out the name. This is Gigabit Ethernet 1. So we validated that we got the right value. Its physical MAC address, how fast it can process data. So some statistics available to us if we wanted to build out a monitoring service for it. Its IPv4 address. This data is structured a little bit differently than, oh no, this is for the particular interface for Gigabit Ethernet 1 and not just for all of the interfaces available to us. The Ethernet stats are, if it was supporting v6, it would have information there, but it doesn't, so that's why we see all the v4 protocols. So a lot of interesting, potentially useful data coming out of that particular API call, but specifically we just wanted to make sure that we printed that data out. We didn't parse anything out. We should have parsed the name out. Did I run out of space here? Let's run it again. I know that this worked. Oh, the bottom of my screen's getting cut off. Here, there we go. So at the bottom here, we parsed out the name, so Gigabit Ethernet 1, to validate that we got the data back for the one that we were looking for. So just a simple example of an API call, but you can see how if we needed to loop through and build a monitoring platform for a bunch of different interface or a bunch of different devices, we can do that all in one place and just make the same API call over and over again to different IP addresses for those particular devices if we wanted to. Now, what if RESTconf isn't available to us and we need to use netconf? And netconf's been around about 10 years longer than RESTconf, so there's a good chance that your device supports netconf. So let's take a look at what that looks like. We will be using a library called NC Client. This is a Python library that was built out to manage these netconf connections from your application to the service. Since we're also using XML, so the output of the netconf interaction is XML, and we will be provided with XML to dictionary. So we'll be essentially doing the same thing that we did with RESTconf, but you'll see that it's a little more complicated, just a little bit, in getting set up to make that call. So we have our IP address port username. The port now for netconf in this particular service is 10,000. And then we're going to set up a filter. So instead of simply saying, I just want interface equals Gigabit Ethernet 1, I'm now setting up a filter for that particular thing, and I have to build out a filter object for that to actually work. So the netconf description requires that if we want to filter data that's coming back, we have to send it a object called filter, and then within that, a definition of that particular filter. The namespace is defined by the Yang model for the IETF interfaces. We are now looking for Gigabit Ethernet 1. So really, all we're doing is querying for the same thing. It's just a little bit more of a pain in the butt for us to do that. Our connection is managed, instead of through HTTP with requests, we're using a method within the NC client inside the manager library, or the manager object, called connect. So this came from NC client, And then there's a method within Manager called connect, and we pass it in its host, port, router, username, and password. That will generate our connection, our netconf connection into that device. We will then call a method called getConfig, and that'll get us our running config. But we're going to pass it in. We have the ability to pass in that filter that we're generating. It'll save that as interface_netconf, and then we're going to convert that XML that's generated out of this interface_netconf into a Python dictionary that Python understands. And based on the way that the data is formatted, we can pull out this RPC reply data, and then that will allow us to then see that XML that we're used to seeing with the information coming back. And so we're able to access the name by going to interfaces, interface name, text. Actually, let's see if we can print all of these so you guys can see the method of these walkthroughs. So we're going to do something on the fly here. It's never a good idea to demo something and then change it. So sit tight, and we will figure out how we got from this running config to this line of code here that's actually going to pull out our name. So fingers crossed that this all works and I didn't type anything incorrectly. Let's see here. Actually happened. And see client example.py. So we're doing the connection. It's taking a little bit of time. We got all of that information back. Okay. So originally, we were only going to print out our interface name, but now I can show you how that data looks coming back when we did that config running. So we have everything is wrapped in this RPC, remote procedure call reply. So that's a defined object within netconf. The namespace is what we expected to see. There's a message ID. We don't particularly care about that. So interfaces, this is what we're looking for. So we have interfaces, the namespace that we looked for, and then we have the interfaces, interface name, text. So if we go interfaces is the first level, and then we have interface, next, name, and then the text for that is gigabit Ethernet 1. So we're able to pull that out as part of our parsing activity. But you can see it's a little bit more challenging because now the construct is coming back in XML instead of JSON. Let's actually look at what ppprint interface Python looks like just for fun. Save that here. We have about a minute left, and we'll take a look at that real quick. Okay, so it had created an ordered dictionary for us, and here's where we get the hash text. So when it creates the ordered dictionary, we have interfaces, then interface, then name, and then it's referencing this as hash text. Not exactly sure why it did that, but that's how we parsed that out. So as we look at that data coming back, being able to actually understand what that data looks like first before we set up automated processes to work with it allows us to then build out things that allow us to get to that information relatively quickly. Unfortunately, I wanted to show you guys an example in connecting directly to the CLI. There is a package called NetMiko, which connects directly to the CLI and allows you to actually send commands that you would send on the device themselves when you're in the configuration interface. Unfortunately, the device that I'm touching on right now doesn't allow that access. So even though it says we can, it doesn't work. I was trying to set up a sandbox beforehand that would get this to work, and I don't have one in play yet. So I apologize for that. I think the biggest thing to take from that is there is a way. So if for some reason you don't have netconf on your device and you don't have restconf, which restconf has only been ratified in the last year, so there's a good chance that unless you're running the latest iOS versions, you do not have restconf, and frankly, I don't think it's supported on all devices. I think netconf covers most of Cisco's devices if you're running any iOS versions that have been released in the last 6 to 8 years. And then if you do absolutely have to connect via CLI, I would try all the other instances before, but there is a way through Python to allow you to automate your interactions with your devices through there. It could be that particular commands that you need to run as part of your interaction with that device aren't supported in netconf or restconf, so you might need to leverage the NetMiko library to be able to run commands that aren't necessarily supported as part of those libraries. I don't know enough to recommend either way, but just keep that in mind. If you hit a stopping point with netconf and you need to actually hit the CLI, there's a way to do it. I'll introduce you to a demonstration of using a web framework called Flask, and then we'll move to another Python web framework called Django, and then I'll point you to some resources that you can use after the fact. So here are some of the Python frameworks that we can leverage. Python and Flask are the Django and Flask are the two at the top that we will be talking about. There's a couple others that kind of fall into the realm of recommended, and that's Pyramid and Bottle. Those two we will not be touching on today, but they are ones that are recommended for production-like environments. And I will discuss the differences between Django and Flask. If you're more interested in the other frameworks, again, I recommend that you check those out, tutorials out on your own. The two tutorials that we will be leveraging to walk through these, or that I leverage to put this content together, because why reinvent the wheel? The Flask, that first URL up top that goes to Miguel Grinberg's Flask Mega Tutorial Kickstarter. I'll actually show you guys what that looks like. One second here. I'm just going to share my screen. So that you can find that here. This is one of the best tutorials I've come across for Flask. It walks you through step by step all of the things that you need to do to get a Flask application up and running, and explain some of the nuances of Flask really well. And I'll touch on them here, but to become a comfortable developer with Flask, this is the place to start. And then for Django, I came across the Django for Beginners, and I also thought this approached developing Django applications similar to what this Flask Mega tutorial did. And so I recommend that as your starting point for, oh, excuse me, for building out applications with Django. Now, that being said, these are beginners tutorials. They're going to give you the basis for those applications. You might be asking yourself, well, why don't I just use the documentation for those particular tools? What I found in leveraging the Flask documentation and the Django documentation is those are good for, once you get a good feel for how the web framework works, then going into specific nuances of those web frameworks, the documentation is good for that stuff. The documentation is really hard to consume, in my opinion, from a getting started perspective, because they don't provide the step-by-step tutorial type things that these two do provide. So what you'll experience as you're walking through these kinds of learning tools is the ability to figure out what the the introductory type stuff is, and as you become better at it, then you start digging into the actual documentation of that particular service to get that running. So that was just my quick comment on tutorials. So what do they do for us? Why do we even need to have this conversation? So if you're not a web application developer, it's really hard to kind of figure out where to start, and the web frameworks do all of the starting for us. They provide us for URL routing. So if you were looking at your browser, and let's actually use the Django for Beginners as an example, they have their straight index page, but what tells their application that if I click on this chapter 1 initial setup, that it takes me to the correct pages for that particular service? It's taking a little bit of time, of course. And let's just make sure. Yeah. Oh, I'm on the wrong network, that's why. I apologize, 1 second. Carlo, are we still seeing my screen?
Yes, we are still seeing the screen.
So apologies, I had to change network. So what is telling me that if I go to the directory initial-setup, that's actually providing me with the correct view into this particular application. And similarly for the Mega Tutorial Kickstarter, those kinds of URL routings are defined if we go to, so this is just the blog post for it, but this is now takes me to post and then the Flask Mega Tutorial Part 1 Hello World. So the URL routes are defined as part of that web framework. It also allows us to provide some output format templating. And what that means is if we look at this page or we look at this page, there is HTML, there's potentially CSS cascading style sheets that define the layout of this page. So there's potentially JavaScript that's tied into that. And you can templatize those things so that as we go from chapter 1 initial setup to chapter 2 Hello World app, that the top of the page looks the same, that the layout and font looks the same, that there is a consistency across your site for all of the pages that you're managing. So that's that HTML, XML, JSON, and other output format templating. And we'll look at those templates as we jump into the web frameworks. There's also some level of database manipulation. I'll do a quick comment on that, but we won't actually dig into database manipulation because I feel like that is an advanced topic beyond the hour that we have today. But know that there are built-in database engagements into Django, and this will be another conversation of leveraging Flask versus Django. So we'll touch on that as we do the demonstrations. They also provide security against cross-site request forgery or cross-site origin attacks. So it builds in the security framework for you so you don't have to think about it. So if you're worried about JavaScript injection or you're worried about services leveraging your URLs that shouldn't be, there are security frameworks built, or there are security methods built into the framework for you that you can take advantage of without having to do that implementation yourself. And finally, because all of the interactions with a website tend to be through users, and most instances of your interactions with websites require some level of session management. So what pages have you seen? What pages are you going to? There is session storage and retrieval that's also managed as part of that. So all of the web application baseline management is happening through these web frameworks. You don't have to worry about all of that stuff and do all of the implementation yourself. It's doing it for you. So that's the nice thing, because it takes all that off of the top of your head. I don't have to worry about the baseline stuff. I can just focus on making my application awesome. Okay? So that's the web framework for you. So now we're going to jump into Flask. I call out the key elements in the slide, but basically from now on we're going to be looking at code and demos. So for our Flask example, there's two things that I wanted to call out. So in this previous slide, we talked about URL routing, and I talked about the fact that when you go from one page to another, what those slash directives mean. Well, you define those in the decorator called app.route. So this is defined as part of the Flask implementation, app.route, and you can then tell it that I want the directive to go to /go, and this is a get method, so the methods support all of the HTTP supported methods, so we could do a get, we could do a post, and depending on the ingestion of that particular route, then we can define a Python application that does some kind of thing. So in this instance, all we're doing is returning what's called a template, and I'll get into the specifics of that when we actually look at the code. It's calling out a specific file, index.html, and it's passing in arguments. So the nice thing about these web frameworks is you have this Python backend that's doing all of the data manipulation, it's doing all of the engagement, and it's able to then push the data that it's managing up then to the front end of the application. So the HTML or the JavaScript or the CSS to dynamically manage your page. And we'll see how that plays out when we get into the demos. For the actual layout of an application, whenever you start a Flask app, two folders are generated. One is called static. I shouldn't say generated. I should say you have to create these. One is called static, and that's going to hold your JavaScript references. That's going to handle your image files. That's going to handle your CSS. That's going to go in your static directory. And then you can reference things back and forth between your back end and your front end through that directory. And then the templates, the actual HTML documentation that's going to be rendered in the browser is going to sit in the templates directory. If you name these something different, Flask will not know how to handle them. So this is one of those instances where the framework itself defines that folder static, and it defines that folder templates as the thing that it's looking for. So if you're referencing static content, you have to put it in the folder called static. And for templates, you have to put it in the folder called templates. There's no deviating from that structure. So that is the definition in the framework for that. So let's actually walk our way through some simple examples of Flask so we can get a baseline for how that application is managed. Atom development environment. And I have two demos on the left here. You can see I have my Django demo and I have my Flask demo, and we'll start with our Flask demo. So let me close all these files so we don't get confused about where we're at while we're working through these things. So we have our Flask demo, and actually before we jump into it, let me make sure that there's no Q&A. I'm not seeing it lit up, so we're all good there. So we have our structure for our Flask demo. We have our parent directory that's holding our entire project called Flask demo. And then everything is managed within a folder called app. So we see, we don't have a static directory because we're not rendering any JavaScript. We're trying to keep the example simple, but we do see our templates directory. And we see 4 HTML files within that. So we're starting out with the correct structure for our particular Flask application. This particular application is launched from a file called flaskdemo.py. So if we open that up, all that file does is from app import app, and basically it is a hierarchical management of this particular project. So what this tells me is I can actually have multiple quote-unquote applications that are part of this project that can interact with each other. And that kind of notion will become clear as we get into Django as well. But this particular one this Flask application has one app tied to it called app. And so we're going to basically instantiate that application in this as we run our Flask application by going from app, import app. Now what that does is that then jumps to our app directory, and depending on how we implemented our app directory, our init.py, that'll tell us what we want to do. So this is actually now getting into the raw Python of the application. So there is a library that you need to install, and I'll talk about that when we actually run the application, called Flask. And so we're going to, from that library, Flask, import big F Flask. So this is our overarching Flask object. So whenever you see a big, an uppercase letter in Python, that tends to indicate that that is a class. We won't really dive into classes today, but understand that there is functionality that comes as part of this definition of Flask. And so part of that is being able to instantiate the app by calling Flask __name __. And then from our app, I'm importing different Python files. I'm importing routes, routes 2, routes 3, and routes 4. Thank you, Carlo, for sharing that link. He just shared the link to the Flask documentation. So all of these, you'll notice, from app import routes, routes 2, routes 3, routes 4, are Python implementations along the side here in our side rail. So we've gone from, just to reiterate, we've gone from our import app. It's now jumped to this, because of the way that the framework works, it's looking for __init __.py, and that's where we actually kick off our application. And then what this is telling us is that we need to then jump into our routes.py to see how we actually do things. So if we look at routes.py, all this is doing is we're doing from app, import app, and we're defining our routes. Now, when we were talking about that slide, how we do our directives for our particular URLs, we only had one defined. In this instance, though, we can define multiple routes for us. So this will actually tie to app.route. So if I go to slash or /index, it will still call this function def index and return hello world. So let's take a look at that and actually start our application so that we can see what that actually looks like. There was a question real quick before I do that. Q&A. Did see, apologies, I thought I saw, maybe it was in the chat. Why am I importing routes? Because this is telling our initializer what Python files to reference for that functionality. So that's why I'm importing those. So let's actually run our Python application. And so I have my terminal up. Just as a quick note, I'm running my Flask demo in a virtual environment, and that's why we see the Flask demo ends note here as part of our terminal. So whenever you're using a virtual environment, that's a clean install of Python. And just to show you guys that only Flask is installed here, I will do a pip freeze. And that'll show us, well, it installed everything that was necessary for Flask to work. So we have our Flask version, and then it leverages what's called Jinja 2 templating. You don't need to really know that, but that's a comment to the what libraries are needed for that. We also have requests, which is able to manage the HTTP requests going to and from the service. So this is our clean environment that we're working from. And because we set our application up properly, all I need to do is do Flask run. There are other ways to run Flask applications, but this is the most common way to do it. So what that does is that'll spin up a local web server that's managed by Flask, and it'll point to my particular, the default port is 5000. So if I head to my browser and I pop that open, for that routes bit, if I just go to slash, it'll say hello world. Because I define both the slash and /index to work in that directive, it takes me to hello world. So that's how those things work. That's not super interesting. Let's start actually building out some HTML to point that out, or to push that data up to as well. So let's open up routes.2. And I should note all of these examples that I'm working for are covered in these tutorials. So the code that is provided for them, I would recommend pointing you to those tutorials. I'm not going to provide these code examples through GitHub, so just a quick note on that. Take a note of those tutorials because I generated this presentation from them, so keep that in mind. So a couple of things that we'll note as different from our previous routes.py. We have from Flask import render template. That is a method within the Flask library that allows us to pass in a reference to our HTML file. And then we're also able to pass in variables as part of that to generate more dynamic content. So within my backend, I've defined this variable user, and it's a Python dictionary that defines a username, and we can call him that user Miguel, since Miguel created the tutorial. And I can pass that into my render template call. And then if we look at our templates within the templates directory, if we look at index2.html, I see the exact same variables now called out within the HTML template itself. So this is how we can dynamically pass content or data from the back-end Python web service to our front-end HTML. And so we're referencing title, and then we're also referencing user.username. And if we go to routes.py, I can access the username value by leveraging the user object.username. So that's how I'm able to do that within Flask. And actually, the little note there is you can use these exact same templates in Django, and we'll see that when we get to the Django example. But that's a quick and easy way to start. You can see as we're working with things in network programmability, if you've attended our other webinars, as we start getting data through our API calls, we can start pushing that up very easily to our front end through these variables that are being passed. So again, whenever I click on, or whenever I call this return render template, I'm able to pass in the name of the template, and then I'm able to pass in variables that I manipulate and manage within my Python file. So if we go to, continuing with our example, index 2, it says now, hello, Miguel. This is now leveraging the template, same thing for 2, since we defined our routes for /2 and /index2 to work the same way. We are now defining the ability to leverage our templates and pass in those variables. And the other thing that when we're looking at here, the title of that is also in the tab at the top of the URL. So let me slide this over so you guys can see that. So this title is now called home-microblog, which we saw in the index to HTML. Okay, so pretty simple stuff, but frankly, if you had gone through the Flask documentation, it would probably take me about half the day to get through it. We got through it in 10 minutes. So hopefully you guys find this helpful as we move forward in these examples. Now moving on, as we're incrementally moving forward, we're going to open up Routes 3. Nothing super different now, but now we see the ability to maintain a lot of content and push that up to our platform. So just like we saw in 2, we're going to import render template. We're now going to call out the routes 3 or index 3. Our user still stays the same, so nothing's changing there. But now we're sending an array of Python objects. So we have, and this looks very similar to JSON, if you notice that. So we have this posts object. It's a list or a list or an array in Python, and each individual entry in posts has an author, which we tie to username with a value of that particular name, and then the body of that particular post. And so we'll see these things get laid out. Now the more interesting bit, now you see instead of just passing user, we're passing the posts value. The more interesting bit though is when we tie it to the HTML, now we can start getting a little more dynamic within our templates. So I'm checking to see if there is a title, and if title is not set there, I'm going to just set it with welcome to microblog. So you can see now with this templating platform, you can have a little more dynamic control within your HTML without having to revert to JavaScript. So JavaScript can be very complicated when you're tying that into your applications. It's awesome with these particular web frameworks that we can leverage what's called the Jinja 2 templating to give us some level of control within our HTML to make it more dynamic. So if I forget to put in the title, and let's actually change that. Oh no, we didn't put the title, or let's not pass this title, and let's see what happens. We're going to do this dynamic. I didn't try that. So we're going to change that to change that call, and then we'll do file save, and we're going to kill our server and restart it. So whenever you make a change, you do that. And let's go to 3. Let's see if it breaks it or not. So that worked out perfectly as we expected. I didn't pass the title in, and now we see the Welcome to Microblog as part of the title of the tab there. And we see our posts show up. We see our name of our particular user, so everything's working as we expected. And we can check index 3 to give us a comfort that our application is working as expected. Now, if I change that back and add in title, now we should see home space microblog if I restart my application. And now we see the title change at the top because I'm now passing it in. So it gives us a little dynamic management whenever we start leveraging these templates. Now, so we've seen a simple rendering, we've seen more dynamic rendering. Now let's think about the fact that we're going to be putting a masthead at the top of our site, something that needs to be always in place for each page. You don't want to necessarily keep recreating that. So for example, this particular site has Django for Beginners, buy the book at the top with a green bar. If I go to any page within this site, that masthead will be there. So if I go to chapter 3, it's going to be there. If I go to chapter 4, it's going to be there. So as you're starting to build these things out, being able to make those masthead changes, say you wanted to change the color of your masthead, you're going to want to do that in one spot. And so you want to modularize it. And so what you can do is you can create a base and then extend it. And so if we look at index 4, actually let's start with routes4.py, we see nothing different. All right, everything is the same. We're sending our posts. And we're now just changing the routes that we're looking for. We're passing in our title, user post. So the Python in and of itself is the same. But if we look at index 4, now we've kind of boiled it down pretty nicely. And the first thing that we're rendering is this extend base.html. So now this is a reference to this base.html file that has now taken the title logic, and if title is passed in, set up our title name --Flask demo. Welcome to Flask demo. And then it'll put in a masthead. So if you have multiple pages that you want as a part of a menu, you can start building that out as well. This will show up on every page that is rendered that has this extend base.html in it. And then we can call out our specific block content. And the other thing we didn't see was our ability, or the other thing I didn't call out in our previous example was, so I talked about the if, else, and if area, but I didn't talk about the posts, how the posts were managed. So we also have the ability to render collections of data using for loops. And the vernacular for that particular, the syntax for that particular item is very similar to Python. You will notice that you do have to call out the end for that. So it's not exactly like Python where indentation matters. You do have to call out the end point. So if you're working with if statements, you say if, and then you have to make sure you have end if. If you're using a for loop within your template, you have to call out for and end for. But then this allows us to loop through pieces of data. We're not statically setting all of that up. If there were 3 posts, if there were 5 posts, they would all show up as part of this for loop. So as we go to routes and send in those posts, Now I've put all the masthead and base HTML. I only need to focus on what the routes for is supposed to do. I don't need to worry about the overhead of the masthead. And I can pass in the username for posts in post. It'll pull out the author username. It'll pull out the post body, N4, and that's ending our block of content. Now I could put other HTML in here if I wanted. That would allow us to make these pages, like I could put a footer at the bottom. That would allow us to maintain some kind of menu. And that's how you start building out these templates, so that anytime you create a new page, you only have to worry about the new part. So you can see as you start building out these pages, if something changes or whatever, you're only focusing on that particular route. So let's see what Route 4 looks like when we go to our application. Index 4. And then we have our menu at the top, as we expected. We have our title that's put in because we passed in that. And then we have our dynamic content under that line, as expected. So you can see this incremental building of applications as we move forward, and that's probably only the first, let's see here, in the Flask Mega tutorial, it was only the chapters 1 and 2. And basically it gets you really comfortable with how a Flask project is set up so you can move forward into things like web forms and databases and user logins. So he covers, and all of this one is particularly for free. And so if you follow through all of these chapters, you'll be able to build out a pretty substantive application in Flask. Now, the reason that I'm talking about multiple platforms is that Flask, from a web framework standpoint, is, as you can see, quick. It's easy to implement. It's lightweight. It gives you some choices as far as tying into databases. You're not tied into one database or another. And so it's really good for proof of concepts. It's really good for little applications that only a few people are going to use at a time. Actually, a Flask application that is run classically on a web server does only support, I believe, 3 connections at a time, which does not scale very well. So it's one of those things that as you're prototyping stuff, Flask can be really good. The reason that I talk about Django is that it's more recommended for production level type web applications. We particularly in DevNet use Flask because a lot of our coding happens to be for demo purposes. It happens to be for learning purposes, and we don't want necessarily people to get bogged down in all of the nuances of something that's a little more heavyweight than Django. So as you're doing an evaluation of web frameworks, understand how those things scale, because you want to be able to, or you could want to be able to have dozens of people using your applications at a time, hundreds of people using your applications at a time. And Flask in and of itself does not support that. Now, that being said, I'm just going to make a quick note about a project called Zappa. And this is mainly just for something to sit in the back of your head. The Zappa project, what that does is it generates serverless Python applications that tie specifically to AWS Lambda functions. So when I say that Python Flask doesn't scale well, if you tie it into a serverless if you tie it into a serverless service, such as Amazon Lambda, or I think Google's similar project is called Google Functions, you can then scale that application out really well, because people that are interacting with your Flask app are only doing it per connection instance, and they're getting a dedicated instance of that application in serverless. So I know that that is a complicated thing to wrap your head around, but as we're moving into different ways of deploying applications in the cloud, we don't have to be pigeonholed by an Apache or a Tomcat service that is sitting at one URL. We can start leveraging these cloud services to dynamically spin up and spin down instances of our application for that. And Zappa, again, is one of those things that lets us deploy a Flask application. And this is just a free open source GitHub project that allows us to deploy Python applications into the web very quickly and easily into AWS Lambda. But specifically, it's really nice for Flask because we have that web framework and we can create websites very quickly. Now, the caveat to all of that is that website has to be stateless. So when I say stateless, I mean that I can tie a database to it, but that database has to be outside of the service. So each time a person moves from one page to another, you either have to pass the state of the previous page to your next page if it's something that you need to manage, but it's not always the best solution. So it just depends on what your application has to do. And so I just wanted to mention that as an option. These things can get a bit complicated, but if you start looking up keywords of deploying web applications, tools will start to pop up to the top for what you want to do. So if you're deploying something that's, for all intents and purposes, quick and dirty, a Flask application will suffice, and you can deploy that to AWS Lambda as a Lambda function, a serverless function within AWS, and people can then access your application publicly without you having to do a lot of extra work. You don't have to generate SSL certificates. You don't have to maintain your own web server. You don't have to make sure that the CGI bin directory on Apache is working. So all of those back of mind things or back of house things kind of go away when we start looking at deploying to the cloud. Heroku is another good place to deploy cloud applications and make those available relatively quickly and easily. Both of these tutorials walk you through how to deploy your application on Heroku. So making them available to, actually this one's a Linux, Heroku, and Docker containers. So the different ways that you can deploy web applications. But again, Flask is just to drive that point home, Flask tends to be used for more in-house proof of concept type use cases. All the applications that you could be running within that Django project. And then we can define different apps, quote-unquote apps, within a particular project through the hierarchy of that particular project. And in this instance that we're seeing here, we have an app called Routes. And each individual app has a file tied to it called admin.py, apps.py, models.py, test.py, urls.py, and views.py. And again, back to the similar point with Flask, these are the framework definitions of the things that it's looking for. And so all of your implementation exists within this directory. You can change the names of these files. It's not necessarily recommended because when you start creating the settings file for a particular Django demo or for a particular Django project, being able to reference the same hierarchy is recommended. So as you get more comfortable with it, you might feel more you might feel more comfortable being able to change the names of the Python files to something that they're doing. But this structure tends to keep things pretty clear. Controller methodology, whereas Flask was a little more loose in its implementation. Django has specific things that it's looking for and ties those into the definitions. So we get our website functions from something called the views area. So this is our view. You see similar interaction that we saw with Flask, but it's a little bit different. So instead of render_template, the function that's defined within Django is called render. We're going to process that request and then pass in the template name, and you can see that we pass our variables a little bit differently. in the context of that particular application. We also see that page routing is a little bit different as well, and so we define that as something through URL patterns. So so we see, we could just see from the fact that this slide has a lot less in it and this slide has a lot more, there's a lot of overhead with Django. That being said, because of the way that the files are structured and the implementation is done, it scales a lot better than Flask does in a production environment. So to do a compare and contrast with what we did in our Flask demo, let's open up our Django demo. And the first thing you'll note is that each individual, and I didn't have to implement it this way, but I thought it would clarify the ability that in Django that you can have multiple applications within a particular project. I had each individual route that we defined within our Flask application as a separate app within our Django project. I could have managed all of these within this particular application if I wanted to, but from a hierarchical management standpoint, it made more sense to me to do it this way. And then for each individual route definition, I have a separate apps.py, I have a separate urls.py, I have a separate views. There is a concept of models, and I mentioned that. I felt, given the time that we had, that it was probably a little too complicated for today's discussion. The other thing that you'll know is that inherent in a Django application is an instance of SQLite3 or SQLite3. And so there is a tie into that specific database for Django. Now, that being said, you are not limited to SQLite3. You could implement other databases as part of your Django application, actually whatever one you would like to do. But out of the box, they generate that SQLite3 for you. And it's tied directly into their administrative function as well as part of your application. Whenever you create a Django project, there are a couple of things that happen. There are commands when you install Django that you can run to generate this particular directory that generates the wsgi.py file, the urls.py file, and the settings.py file. The other thing is you generate your project, and then you generate apps within that project. And every time you generate a new app, you generate a directory that includes this migrations bit. And again, the migrations are tied to the model, so we're not going to talk about that then. I just want you to know what's created when you create your app. It creates an admin.py, an apps.py, a models.py, a test.py, a urls.py, and a views.py as part of that application. And it will automatically seed those files if it makes sense to seed them. So I didn't make any changes to this particular file, but it started, you can build your test cases within your application, and for that test.py, it allows us to do that as well. You can see there's a similar structure to what we did in our Flask application, but there's a lot more overhead to it. Now, the templates directory is sitting at the top level of our project. I could have a templates directory within each of my apps as well. It just depends on how you implement them, because or how you want to implement them, but it's always looking for a templates directory, similar to what we saw in our Flask demo. And in that, we can define our individual HTML files and tie those to those templates. So what you're going to notice is that each of these templates are exactly what we saw in the Flask demo. So it's using the same templating language, same templating platform. So if you prototype quickly in Flask and then want to move your application to a Django project, you can leverage the templates that you already used to do that. Now, that being said, the implementation of the Python is a little bit different, and we'll get into that now. So for our Hello World project, where we just printed Hello World into our browser, there's 3 files that we need to take a look at. So let me close everything here so we don't get lost. So the first one is apps.py, and As part of the Django library, we have a Django.apps, and we're importing app config. And this is basically just a constructor for our particular application. I'm going to call this routes config. It's extending app config, and we're just naming it. The big parts that are the implementation bits are the URLs and the views. So in the views, this is the function that is actually doing the work. We're providing some level of HTTP response that's managed within the Django platform. So just like we talked about earlier, the framework is providing all of the HTTP interaction for us. We don't have to worry about implementing it. And I'm returning an HTTP response, hello world. No templating, nothing super crazy going on here. We're just going to print that out. Now, like we saw with setting up the routes in Flask, we do that with what's called URL patterns in Django. And so Django has a hierarchy for how it actually looks for resolving HTTP or resolving URL requests. And you can define those explicitly. It tends to use a regular, or it tends to, it implemented to use regular expression wildcards to figure out what the best result should be as part of its implementation. But we are calling this out specifically. So we have from Django.urls import path. So this is another library within the Django package and we're importing a method called path. And then from our .views, we're importing that index page view. So this is a reference to the views or the function that we implemented in views.py. So whenever someone calls the empty path, then we're going to call that index.pageview function, and we're going to give it the name of index. Same thing if we call the index path. And so these are going to render the same thing, just like we saw in the Flask application. So I'm going to start up my Django app. If I don't have it going already, I do not. So this is run a little bit differently, and the tutorials will walk you through the commands that you need to put in to create the project, the commands that you need to do to create the app within the project, and then finally to run the server. It actually ties in a lot of code management bits as well. I have to say both tutorials are very good about where you put your code and being able to update that from a code revision standpoint, because that all ties together. Again, I didn't have enough time to do that. I just wanted to expose you to these things so that when you got into those tutorials, they made sense. But I'm going to run my server here. I'm now running on port 8000 for that particular project. So if I head to my browser, and we'll open up a new tab, and I go to 8000, we see our hello world. So a lot to get to that point, but now we have a baseline for adding in more things. So just like we saw with our routes2.py in Python Flask, we have now the routes2 app within Django. If we look at apps.py, it's just a initiation of that instance. One thing I completely forgot, and I apologize. So within settings.py, at the project level, we talk about the applications that are installed as part of this service. There are standard ones that are installed as part of Django. You do not have to keep these in here if you do not want to, but these are created out of the box. And again, the tutorial will walk you through this. But since I have 4 apps now created in my particular project, I needed 4 new entries in my installed apps. The first one that we just looked at was routes.apps.routsconfig, and that made reference to our routes directory here. We're going to go off through routes 2, routes 3, and routes 4. And because of the way that the framework is set up, it knows that as it walks through and evaluates this installed _apps array to bring in all of the directories and all of the Python files for the directories in these particular services. So that's the top level how you manage that. There are a couple of other nuances that allow us to use the templates directory at the top level rather than each individual app having a templates directory. That particular nuance is called out specifically in the tutorial, so as you walk through them, you should be able to quickly see how the hierarchy works within a particular Django application. As we move into routes 2, we saw something a little more complicated where we want to actually pass in variables. We're going to call the title home2. I've changed the username to my name, Maddie, and I'm tying into the template name index2.html. And now we're calling render. So this is Django.shortcuts import render. That is this is a little deviation from the tutorial, but this is a way that we can tie it back to compare and contrast with the Flask application that we did. But we're passing in the request that has been now passed into our function. We're going to send in our template name, and then this is how we pass our variables up to, drumroll please, the index template that we're working with. So now the title and the user.username are going to show up. You'll notice that the template is exactly the same as the one that we used in Flask. They use the same templating platform. So if we were to go to index 2 or 2, then we will see hello Maddie, just like we saw in our Flask application. Now, moving to route 3, you're going to see a similar buildup, and that's why I left a little bit of, or I didn't leave as much time for Django, because the pattern is such that we have our apps.py that defines our class, and it ties it back into the settings. We have our urls.py that defines our call out to, so urls.py for 2 looks like this because we implemented that index page view 2 method in our views.py, index page view 2, so that's how that all ties together. And we'll see that as we go through the third route, index page view 3, and the particular URL patterns for that. The views in this instance now, though, we're building out our user, we're building out our posts, and we're passing all of that in our render situation. And so if we go to 3, as to be expected, we're going to see our post show up. We'll see our title change to home, 3 at the top, if you can see that up here. And we have our, I changed my name to Matt Dog. It's a beautiful day for learning at Cisco, and DevNet is so cool. And then finally for 4, the same idea as we add the extension of the base HTML and the same username, same posts, the methodology of that particular routes.4 app is the same as we saw with 3 and 2. It's just a new implementation of that particular app. So changing the title, the template name is now index 4. I changed the user name to Ratatat. For some reason I thought that was funny. And as we look at our URLs, they are referencing that method, index page view 4, and then the routes. So if we go to 4, we can bring that up. Now, and then we also have our base HTML reference at the top, which will take us back to index. Now that all being said, this is a compare and contrast of Django, of a Flask application to a Django application that does the same thing. What you will do with the Django tutorials, you'll start working through what's called class view implementations, and I think that the author does a really good job explaining the nuances of these things, so that instead of it being function calls, it'll be class manipulation within Python. I think it is worthwhile. You don't need to know this as much with Flask, but it is helpful to understand what classes are in Python when you get to Django, because then as you work with the models of the data that you're going to be working with, those are always implemented with classes. So it's worthwhile to understand what a class is in Python. You can probably knock that out in about a half an hour. Look up classes in Python. It'll do a description of what that means. And then as you get into your more complicated Django tutorial pieces, you'll understand how that fits into the application. The whole idea behind Django is to manage everything hierarchically and to make it so that you're not repeating yourself as you go across apps, templates, or within a particular app in and of itself, so that you're only doing something once, and if something changes, you only need to change it in one place. So as you're building out these applications, if you're getting into an instance where you're implementing the same thing over and over again, Django is designed to keep you from doing that. And so you're probably doing something wrong, and you should take a look at, have I designed my web application properly? Those are a little more complicated things than what we have time for today. That is all I wanted to cover. Please check out those tutorials. I think they're fantastic.
So what I'm going to cover today is, why do we want to do Python? Why Python over Java or Go or any of the other languages? Then we're going to go look into the Python basics, then take a little step further and look at Python conditionals and loops. And lastly, we're going to look at the Python scripts and how to execute them. So why Python? Python is an interpreted language versus a lot of the other languages which are a compiled language. So because it's not a compiled language, you don't actually need to compile the code before it can execute. A big reason why people want to do Python is that it's easy to understand. So when we will see later, when I'm going to show you some of the Python code, the code reads like English. So when you read it out, it's almost as if the way you're thinking of what you need to do is typed out in code. In a lot of the other coding languages, you're going to have a lot of like brackets, curly braces, semicolons, and a lot of unnecessary syntax that causes syntactical errors or just blows up a lot of your code in terms of lines of code. And that leads to Python being easy to code because it's easy to understand and removes a lot of syntax. You can do a lot of powerful things with less code. Before, if you're doing C, sometimes you can have thousands of lines of code, and you can do the same thing using Python with maybe a couple hundred lines of code. That is a huge difference and makes it a lot easier to read, a lot easier to debug when you have issues, as well as easier to share code and understand it. Python scripts are very simple. They are in UTF-8 text files, and because it's as a text file, you can actually edit it in any type of text editor. Even though you can edit in any type of text editor, even Notepad or TextEdit, it is recommended to have some sort of text editor that it can read programming languages, so like a Python-specific text editor. That way you can have a lot of the Python syntax highlighted, helps you with any syntactical errors that you may have while you're coding, and it just makes your life a lot easier. So Python maintains two stable versions. Currently, the two stable versions is Python 2.x and 3.x. It took people a little bit of time to migrate over to Python 3.x, but it's been out for quite some time, so a lot of the different things are migrated over to 3.x. And for this version change, Python 3.x is not necessarily backwards compatible to 2.x. And that is very important because, as we're going to talk about later, Python has a big online community, and there's a lot of code that is shared through open source. And so when you pull down code, you need to make sure that you're grabbing the code for the right Python version that you are using to code as well. Python, as part of the install, includes pip. Pip is a utility that helps you install these packages and their dependencies. So before, when you would need a particular package, you would actually have to go and download that package yourself and include it and deal with all of that. With Python, you can use pip to install different packages, and it will come with all the dependencies that it needs, and it just makes it a lot easier and cleaner. So Python also comes with an interactive shell. The interactive shell is essentially what Python is doing while it is executing your script. Why this is actually nice is because let's just say that you pulled down some sort of library, but you don't know how it is used, or you want to see what kind of functionality there is. You can use the interactive shell and type in that code directly to the interactive shell, and that will help you see what you need to see without putting it in a script and executing it and doing it, taking that path. That path can be done, but it just takes a little bit more time. And lastly, Python has virtual environments. What a virtual environment is that it's an isolated environment on your system that will allow you to have an independent, clean environment for you to start your project. A lot of times, especially if you're a developer, you work on multiple projects at the same time, and they may not need the same dependencies and packages. Or maybe they do, but they need to be in different versions. So let's just say that you have a project on Python 2.x as well as another project on 3.x. You can isolate the two and make them independent so that they're cleaner and only have installed what you need. So it seems like Python's great, but why Python? Python's very powerful. As I mentioned earlier, you can do a lot with a little bit of code. It is also flexible. In a lot of coding languages, you can only build certain things. Like there are certain coding languages that you can only do the front-end UI versus the back-end UI. But with Python, you can pretty much build anything you want. You can do shell scripts, back-end web APIs, front-end UIs, databases, machine learning, and many, many other things. It is also, there's platform flexibility. When you are dealing with the compile language, you actually have to compile it with that particular OS version, or it can only run on certain types of platforms. But with Python, because of its flexibility, you can run it on a laptop, a server, a VM, container, as well as many other platforms. So it just makes it where you can do code in one sort of platform and it can run in multiple different platforms. Domain applicability. As I mentioned earlier, there is a big online community with open source, and people share code with each other. Even at Cisco, there are, for example, there's the Meraki APIs. I know that there is some Python packages that uses the Meraki APIs so that you don't have to worry about them, and you can just call these Python packages to call these REST APIs. And you can also share code with other developers. Let's just say they wrote something that you need and they're willing to share with you, and they've already put it on the open source out there. Then you can pull that code easily and start using it rather than starting from scratch. So there's a lot of people who utilize the online community and open source, and they're able to start their projects with code that already exists. Therefore, you don't actually have to do as much work. You can just take what's there and then modify it to how you need. Just like most coding languages, here are the basic data types. There is the integer, which is a positive or negative whole number. The float, which is a positive or negative decimal number. Boolean, which is true or false. And what you'll notice here is in Python, true is with a capital T and false is with a capital F. There's a lot of coding languages that uses lowercase for them. And then there's a string, which is text that's in quotes, and we were going to dive into strings right after this, as well as bytes. So these are the basic data types. I think they're pretty self-explanatory. They're kind of used in everyday life. So let's dive into strings, because strings are pretty useful in terms from a coding perspective. We use strings to print out statements on the display. We use strings to take in data, lots of uses for strings, so let's go take a little bit deeper look into it. Strings are any Unicode text, and the nice thing about strings in Python is you can use single quotes, double quotes, triple quotes. Why do we have all of these different options in Python? Well, it allows you to combine single quotes and double quotes to actually have quotes within the quotes. So for example, let's just say you have a string that is somebody quoting, making a quote. So in this example over here in the nested quote, it says, he said, quotes, I love Python. So the fact that there's single quotes and double quotes, you can have started with single quotes and put your quotation within the string. Another example is if you had an apostrophe in the string. If I said Denise's Python class, you can start the string with double quotes and the apostrophe will not mess up the string quotations. This makes it a little bit easier because in other coding languages, it only uses one type of quotes, and you will actually need to escape the quotations or apostrophes in your string, which can get a little bit messy. What are triple quotes used for? If you see over here in the example on the right, the triple quote, if you wanted to have your string to be on multiple lines, you can use the triple quote. Another way of doing it is also just using the new line character, but again, that can get a little bit messy and it's just harder to read. So this all goes back to the very first point I made about Python, about how it reads like English. It makes it easy to read. You don't have to worry about knowing what the escape character is. You just type it out as if you're reading it in a book. Now working with strings. Strings have a couple operations. You can concatenate it with the plus, and you can multiply it with the asterisk. So in the example on the right, if you had the string ONE for 1, you can add that to the string 2, TWO, and it's going to concatenate it. What you will notice is that it doesn't add a space in between. It's just literally concatenating the two strings together. If you use the asterisk for the multiplication, what it will do is it's going to take the string and it's just going to repeat it that many times. So in this example, ABC is repeated 3 times. There's also some useful string methods. There's the composition of format. And in this example, it goes, hi, my name is, and in the curly braces, it's going to fill in whatever you pass into the format, which in this case is the string Chris. So the end result is that it says, hi, my name is Chris. You can also split the string. Let's just say that you have a sentence and you want to manipulate the words in your sentence. You can split it against the space, and what it'll do is it's going to create a list with every item of the sentence between the spaces. So in this example, Python is cool is a sentence, and we're splitting it against the space. So Python's going to be the first item of the list, is the second, and cool is the last. We're going to talk about lists in a little bit in more depth. Then there's the join. Join essentially is the opposite of a split. It's going to take a list and you can add in some sort of delimiter. This one's kind of nice because there's, in a lot of different things, you might be dealing with CSV files, which CSV files are comma delimited lines. And so you can take each line and do a join and create the CSV file. So that's what is very useful for it. And lastly, what I'm going to show is the length. If you have a string, you might want to know how many characters are in the string, and you can use the length, LEN utility to get the length of the string. All right, now that we've talked about strings, let's move on to variables. Variables is pretty much just reserved memory to store a value. What type of value am I talking about? Well, we talked about the basic data types earlier. You can store an integer, a float, a string, any sort of data type into a variable. You can kind of think about it from a real-life example of a calculator and how there is a memory storage on there. You're just storing a particular variable where you can utilize later. In Python, this is different than a lot of the coding languages, but every variable in Python is an object. We will touch upon objects later on in this webinar. Variables are assigned using the assignment operator, and that's the equal sign. So as you see on the right, you'll have a variable, you use the equal sign and give it a value. The nice thing about variables in Python is that they are type agnostic. What that means is that you don't have to declare what is the data type of your variable before you actually create the variable. In other coding languages, you'll actually have to say, my variable A is an integer, and the only values you can store in A is going to be an integer. If you try to store any type of string or float into this variable A that I've already declared an integer, it won't work. With Python, it removes all of those rules, and you can create a variable and assign it to anything, any data type. And then later on, if you want to reuse this variable, you can actually reuse it and store and assign it some other data type, and it won't blow up like a lot of the coding languages do. The variable names have some rules. It cannot start with a number, it can't conflict with the language keyword, and we'll see some language keywords later, but examples of them are for, in, and then it can only contain alphanumeric, an underscore, as well as a dash. If you use a text editor that is that understands the different programming languages and it is Python is available for it, it will highlight whether or not it is a language keyword, and it will let you know that it is that variable name is not going to work. So if we take a look at the example on the right, I have the variable B, and I'm assigning it the number, the integer 7. Then I'm creating a variable C and assigning it the integer 3. Then I can create a new variable A, and it is going to be assigned the value of B plus C. So B is 7, is going to add C, which is 3. So A, when we see what A is going to be 10. Now we can take that same variable B and assign it the string foo, and C to be the string bar. And if we do the same operation of A equals B plus C, A is now going to be the string foo bar. So as you can see in this example, you could change the data type of the variables, and the variables can be reused. So now that you know about variables, there's also a concept called variable scope. What this means is that, yes, you could create a variable, but you might not be able to use it everywhere depending on where you create the variable scope. There are two types of variable scopes. The first one is global, or also called module variable, and you define those in the main body of the Python script, which is outside of any function or class. The only exception is that if you're in a function and you use the global keyword, then you can also create a global variable that way. So what is the scope of a global variable? You can actually use this variable throughout the whole file or module, and any file that imports this particular Python file. So like I mentioned earlier, you can share code, you can create packages, and if somebody's importing this code, they can actually use these variables. You can also use it in, because it's the whole file, you can use it in every function. Usually one of the common mistakes when you're beginning to code is that this is the easiest way to go. but it really should be avoided when it's unnecessary. If you do a little Google search, you'll find Google search on global variables. A lot of people will say that global variables are very bad. It's not necessarily bad, but it just needs to be done in the correct manner. It's almost as if you gave your Wi-Fi password to everybody in the building, and they might not need it, but they just have it. So you just want to use it when you need to actually use it. One thing about Python is that Python doesn't have this data type called constants. Constants are usually some sort of value that you know will never change. In coding, constants are typically used for, let's just say, strings of the product name. Something that you may want to change somewhere in the code, but you don't want to write that everywhere in the code just in case it changes. So let's just say that you have a product named, like the iPhone. Let's just say they're going to rename that. And you can put that as a global variable, and if that product ever gets renamed, you're only changing it in one place. Because Python doesn't have that concept, a lot of people will just create a global variable and use all caps to say that this is a constant. And that is pretty much accepted throughout the community, and that's kind of how a lot of people use global variables for constants. Now let's get into the local variable. What is a local variable? They're defined within a function or in a class. And because they're within a function and a class, that is the only place where you can use these variables. But not, and I want to clarify that it's not amongst all functions or all classes. It's that particular function that you put it in, or that particular class. So if you created a function that is called add with the variable a, you cannot use that variable a in a function called multiply unless you create your own local variable. If you are within the function, and let's just say that you have a local variable named a and a global variable named a, it will check the local scope first before going to the global scope. So your local variable will be the one being used first before it goes and checks global. One thing to note is that function arguments, which we will cover later, are local variables, and they can only be used within the scope of that particular function. So I mentioned a little bit earlier when we're dealing with variables that in Python, everything is an object. So what is an object? Objects are an encapsulation of variables and functions into a single entity. What does that mean? So an object can have extra utilities and methods and attributes. I kind of look at it as you might have a building, and inside you have a lot of different rooms, and so the object will be the big building, and you can have a lot of methods within it. To access these methods, you will use the dot syntax. So you can view the type of methods that are available for this object using the dir utility. And a good terminology, just for terminology's sake, when we're dealing with within the object, a variable is usually called an attribute and a function is called a method. So if we take a look at the example on the right-hand side here, if we assign the variable a 57, this a is an integer, and if you use the dot to access the methods within a, there is a method available called bit length, and if you call the bit length method, you will get the value 6. Now, if you have the variable b and you assign it 3.5, which is a float, and there is a typo here, but if b dot is integer is a method, then it's going to say false because it's not an integer, it's a float. to continue on to these examples, if we have a string that is in upper and lowercase, and you wanted to make it all lowercase, you can use the dot lower method, and it will help you put all of the text in lowercase. To view the methods within a particular variable, you use the dir, and you can pass in that object, and it'll list out the different methods that you can use. And this is just an example of that. So moving on, hopefully you got all of those concepts, and now we're going to go take a look at the advanced data types, which are collections. These are pretty good to know because if you are dealing with modern usage of Python, a lot of people use Python to call REST APIs, and REST APIs and a lot of the responses back that you get from REST APIs have a lot of data in it, and dictionaries you're going to find very useful for that. So there are different collections available in Python. There's the list, as it kind of sounds. It's basically an ordered list of items. In Python, these lists allow you to have different data types. That's one of the pros of Python being not particular to particular data types. It can contain duplicate items, so in your list you can have multiple items of the same value, and it is mutable. So you can change one of the items of the list after it's been created. Then there's the tuple, which is pretty much like a list, and the only difference is that it's immutable, so it cannot be changed after it's been created. And lastly, there's the dictionary. It's using the keyword DICT, and a dictionary is an unordered key value pair. If you see here in the example, here the string apples will be the key, and the number 5 is the value. The keys have to be unique and cannot be changed after it's been created, but the keys do not have to be the same data type. And that's also the values. You do not have to follow the same data type for it. So going deeper dive into collections, for a list, you will notice that you use the bracket to create a list. So if you have a variable L and you're trying to create a list, you'll use a bracket, and then you're going to give the items of the list. In this first example, it shows that you can have a string as one item, an integer, and a float all in the same list. You can actually put a list within a list. It gets a little bit messy, but it's possible. To access each item of the list, you will put the variable name of the list, put the bracket, and then you're going to give it an index. If you notice in this example, L passing in an index of 2 gives 18.2. But that's actually the third item in the list. In most coding languages, you will be indexing off of 0. And so by indexing off of 0, the string A is the first one, or string A is index 0, the number 1 is index 1, and then 18.2 is of index 2. Now, when you do an update on them, you pretty much use the same thing of how you are indexing, accessing the value, but you will just use the assignment variable to pass in the value. And afterwards, when you access that variable, you'll see that it's been changed. Now for tuples, the only difference is that it is using the parentheses versus the bracket. But other than that, everything is the same. You cannot update it because it's immutable. And then there's the dictionary. The dictionary is using the curly brace, and you're going to give it some sort of key and then use a colon and then some sort of value. In the dictionary, just like everything else, it is comma delimited to do every single item of the dictionary. You access the dictionary in the similar way where you're using the brackets, but you're going to pass in the key that you want the value for. So in this example, we're using D, passing in the key oranges as a key, and then it is giving you the value of 9. You also have the option of using the .get method that comes with dictionaries. So it's pretty much the same, but rather than using the bracket, you're doing .get. You update it pretty much the same way as you would access and using the assignment operator. We're going to start off with the conditional expression. We're going to get into it, so we're going to start from the top and understanding the expressions that you need to use for these conditionals and loops. For expressions, the typical syntax is you have some sort of operand, and then you have the operator, and then another operand. So what is an operator? We're going to go with the middle first. If you look here on the right, then you have the typical operators that you'll see, which is less than, greater than, less than or equal to, greater than or equal to, equal, not equal, and the contains element. Over here, if you look at that, that will be the operator in the middle. The expressions have a minimum of 1 operand, and even though I had showed operand, operator, and operand, the minimum that you can have is 1 operand. If that operand is a Boolean, that will already help you determine whether it's true or false. Operands can be either a variable or a value. So you can have a variable, for example, x, or you can have a value like 10. At the end, when you evaluate this expression, it's going to get evaluated to a Boolean. So in this case, you're just saying, is the value in x less than 10? It's going to be a true or a false. Now that you know about expressions, then let's add logical operators. Logical operators basically just join together expressions. So you're going to have an expression just like our previous example. There is x is less than 10, and then you're going to create add an operator. So if we look at the right, there's the logical operators, which is or, and, not. The way or works is that you have one sort of expression, 2 sets of expressions, and these expressions are going to be Booleans, like I had said earlier. If one of the expressions is true, the result is going to equal to true. If none of the expressions is true, then the result is going to be false. And then there's the AND operator. For the AND operator, both of the expressions has to be true before the result is true. If one of them is false, it's going to be false. Then there's the NOT, which is basically doing the opposite of the Boolean. So if it's true, NOT to the expression is going to be false, and if it was false, it's going to go true. So when you go and put in 2 expressions together with the logical operator, it's also going to be evaluated to a Boolean, and you can see the result in the table on the right. One thing to remember is that there's actually an order of the way that these expressions are evaluated, and it's going to go from left to right. So this expression 1 is always evaluated first before it goes to expression 2. So for an AND, if expression 1 is false, it automatically knows that the whole thing is going to be false. You can combine multiple logical operators. So you can have x is less than 10 and x is greater than 0 and x is, I don't know, greater than 2, which it's kind of a little bit redundant, but I'm just using that as an example. Now that you know about expressions and logical operators, then we can talk about conditionals. Conditionals is the typical if, else block. And you kind of look at this as just the way that you will think logically in your head. You know, if today is sunny, I am going to wear some sunglasses. Else, if it's raining, I am going to bring an umbrella. So that is why we say Python's easy to understand, because the way that these if statements are written, you can kind of talk through it as if it's English. For conditionals, indentation is important. You have to indent the statements that you see within the if and else if else blocks. If you do not, the Python's going to get very confused and probably give you a syntax error because of that. For spaces, indentation is recommended. There's usually a big debate amongst developers what is the best to use. In Python, they are very it is very picky about tabs and spaces, and it will not run if you have mixed tabs and spaces. So you got to stick to the same thing. In conditionals, you can have nested if statements. Sometimes it gets very messy, but sometimes it's necessary. So what I mean is that, let's just say using the syntax in above, if you have expression 1 and that is true, you are going to go into statements 1. So that could be multiple statements. Within statements 1, you can actually have another if-else statement within it and evaluate even further. One thing to know is that when reading these conditionals, if expression 1 is true, it's only going to execute statements 1, whatever that whole list is. It will not touch what statements 2 or statements 3 is going to do. It's just going to do what's in statements 1 and then pop out of the conditional. If expression 1 is false, it's going to go to the next else if and check if expression 2 is true or false. And depending on that, the else statement is pretty much a catch-all at the end. The else if and the else statements are optional. You can always have just an if statement and that's it. So if we go look over to the right, I have an example where it says the variable b is equal to the integer 5. Now, if b is less than 0, so we are going to plug in what b is, which is 5. So if 5 is less than 0, that's false. So we're going to go to the next else if. b, which is 5, is equal to 0. That is false. So we're going to go to the next else if. So b being 5 is greater than 2, which is true. So we're going to continue. And b, which is 5, is less than 7. So that's true. So with the and, remember I had said that it has to be true on both expressions, which in this case it is. And this is a true expression. So it's going to go into the statements. In this case, we only have one statement within the else if block. And what it's going to do is print out b is between 3 and 6. And it's between 3 and 6 because we're only using less than and greater rather than less than and equal to and greater than and equal to. So 3 is between 3 and 6, or b is between 3 and 6. Loops. There are two different kinds of loops. The first one we're going to talk about is the for loop. The syntax for the for loop is using the Python keyword for. You're going to have a particular individual item, which will be a variable, in an iterator. You typically do loops when you want to do some sort of set of statements many times. So you're going to loop it and do it multiple times. And what it will do is it's going to iterate through this iterator or a collection. And an iterator can be a list, a tuple, dictionary, all the collection things that we were talking about earlier. So with this example on the right, we have a variable called names, and it is a list of strings of names. So we're going to have a for loop. We're going to have a variable called name. And the first thing it's going to do is go to index 0 of this list and assign the variable name to whatever value is in index 0, which in this case is the string Chris. So right now, the value of the variable name is Chris, and our statement says that we're going to just print it out. So as you see below, you're going to see the name Chris. With the print statement, it automatically does a new line. So when it's done with index 0, now it's going to go to index 1, and it is the string Dave. So now the variable name is now going to be assigned to the string Dave, and it's going to go into the statements with prints it out. And it does the same thing for J. So as you can see, it'll iterate through this list and perform these statements for every item in that list. Now we're going to go into the while loops. While loops is with the syntax with the keyword while, give it some sort of logical expression, and if that logical expression is true, it's going to perform the statements. And it's going to execute until this logical expression is false. One thing to be careful of with while loops is infinite loops. If you do not have some sort of expression or something to break out of that loop, you're going to keep on going and it's going to get stuck infinitely. So to get out of the loop, you would use the break keyword, and you can use continue as well, but what that will do is that, let's just say you have some sort of set of statements. If you want to do the first set and then you want to not do the bottom, you can click do continue and skip the current block, and then it's going to pop back up back to the top of the statements and do the logical expression check again. So if we in our example on the right, if we have the variable name I and we assign it to the number 0, it is going to say I, which is 0, is less than 4. That is true, so it's going to print what I is. And then what you'll notice is it's going to increase I by 1. So it is essentially creating sort of like a counter. So now I is 1. It's going to come back to the top and say I is less than 4. I is 1, so 4 is, or sorry, I is 1, and then is that less than 4? It's true, so it's going to print that. So until it gets to the point where I is 4, when 4 is less than 4, that's false, so that's why you only see 0, 1, 2, 3 as the result. Now the second example is pretty much an infinite loop. While true, you're going to print that out. This is an infinite loop because there isn't anything that breaks out of the loop. True is always going to be true, so this while loop will always run, and you're probably going to have to push things Command-Z to get out of that loop. So you want to avoid that. You want to make sure that you put some sort of break statement somewhere to get out of the loop. Functions, I kind of mentioned it earlier. Functions don't repeat yourself. If you ever find yourself copying and pasting any sort of code, even if you have to modify 1 line, 2 lines, something very subtle, you definitely want to make that a function. Sometimes you don't even copy and paste and you want to make it a function so that it's easy to read, so that people understand that this is a block of code. The syntax for function is using the keyword def. You would do def, you're going to give it a function name, and then take in some optional arguments. They're optional, so you don't necessarily need to have them. Then what you're going to do is you're going to add some statements to do within this function, and you can return a value. So the return value is also optional. Sometimes you want to have functions that just perform steps, and that's the end. Sometimes you want to have functions that perform steps and return back so that there's some sort of value that gets returned to the code that's calling it. And so, as I said, the arguments and the value are optional, and as I mentioned earlier, the optional arguments are local variables, so the scope of that is only within the function itself. So again, going to the right, looking at the example, we are defining a method called circumference and taking in some sort of value, which is a radius. If you remember from a long time ago, to get the circumference is 2 pi r. So we are going to create a variable called result, and it is going to do the math operation to pi and using the radius that you got from the argument. You'll notice that I'm using math.pi. Math is one of those packages that you can pull down, and there's the pi that it can multiply out. So I don't actually have to type in, 3.14, and I'm not the kind of person who memorizes what pi is, but that's why I use this library. And what this function is going to do is that it's going to return the result of the circumference. So if I execute the function circumference passing in 2, it's going to give me the circumference with the radius of 2, which you can see as 12.566 and so on. So that is using the optional argument and returning a value. Let's say that you want to create a function that just prints out the text hello. So it's going to define, say hello, to not take in any parameters or arguments, and just going to print it out. So when you call that method, you notice how you don't have to pass in anything in the parentheses, and it's just going to print hello. Scripts and execution. Python scripts, I kind of covered it a little bit earlier. They are text files. It uses the file extension .py and can use any text editor. Like I said before, you should have it. It's easier to just use a Python aware editor. It'll make your life easier. You don't need to compile them, and they're executed with the Python interpreter when you execute them. So I mentioned a lot of times the packages and being able to pull code, but how do you actually use them? Well, you'll use the syntax import. You are going to import that particular package, which we call modules. There's 2 ways to import something. You can import the whole file, which gives you everything that's available there, or you can import a particular method or function that you need in that file. These code that you're importing can be something that you wrote, so you could create a script and need it somewhere else. It can be provided by companies such as Cisco. It can be from other developers. So in this example, we are importing the package called request because we want to make an HTTP request. And to use it, you will do request.get, and then it takes in a URL as a string. If you want to only use get, let's just say you don't want everything else, you just want to call it get, you can use the syntax from the request module, only import the get. And when you do that, you can just call get directly. You don't need to do request.get. One thing that Python comes with is input and output. You use the input utility to take in some data. Let's say that you want to get information from the user. You ask them for an input and then display out with the print statement. Print statements are great for debugging. It pretty much is the keyword print and some sort of string in there. And here's a script example. What you'll notice is that this is the first line where it says user bin environment Python. It's telling the scripting that this is a Python file. And then the first thing, this is kind of common template of how to write a Python script. It's going to do all the imports. So in this example, it's importing the package random. You put all of your constants or global variables here. In this case, I have a constant that's a list of fortunes. Then you're going to start your functions and classes. So there is a function generate fortune. Main, you can actually call this anything you want, but it is pretty much the main method that gets called when you execute this Python script. And in this example, all it's doing is it's going to print out by calling this function up here. And then there's this little nifty if statement down here. It's just checking to see if the main script is being executed. And to actually execute it, how do you actually execute it? After you have Python, you would use either the keyword Python or if you're on Python 3, depending on how you have it installed on your system, you might need to call Python 3 with the file name. If you are using a virtual environment, the virtual environment will already know what Python version you're using, so you can actually use the keyword Python rather than Python 3. So in the first example, if you're in the virtual environment, you do Python and then the Python file name. When I called that fortune script that I showed earlier, it just randomly chooses one of the two and then prints it out. These scripts are executed from the terminal, and what happens when you type in Python and then the Python file, the Python interpreter starts from the first line of the script and executes each statement after that. So to continue to your learning journey, go to developer.cisco.com. That's DevNet's website, and there are more resources there. Some key ones that I'm going to point out is that there's the Programming Fundamental Learning Labs, which covers Python as well as Git and other topics. We have the learning paths, which we kind of call Start Now. It's a page that will tell you the different technologies here at Cisco, and you can click it and kind of do a whole journey. And we have free sandbox environments that you can try out different Cisco products for free. And so definitely check out developer.cisco.com. That is the DevNet page. And if you have any more questions, I'm going to go through the Q&A. I have like 5 minutes, but you can hit me up on Twitter. You can hit DevNet up on Twitter and Facebook and GitHub. So let me take a look at what is in the Q&A and pull a couple questions. Okay, so Carlos had asked, what text editors that understand programming language do you recommend, or what text editors do you use now? A lot of people for Python like to use PyCharm. I've also used Atom. Sometimes I just use Sublime. That is just something, a lot of the common ones. There are many different types of editors. Some are better for particular programming languages than others. Some people have been started using the Microsoft Visual Studio. But I think for Python specific, a lot of people like to use PyCharm. Okay, so somebody asked, why is that word equal apple the command word.lower but works but not word.length? So basically, let me go flip back to the right page. So this is in the strings. I believe that there, who had asked this, David had asked this, and for length is a utility for Python, and it is not as part of the object itself. So that is why this is a length. LEN is a Python keyword versus to lower. I don't remember exactly where I had it, but .to lower is it is part of the object itself. So hopefully that answered that question. Okay, still weeding through them. Somebody had, do you know a good site with exercises to practice all of this? I mean, so in our learning labs, which I have showed at the end of it, DevNet has some resources. If you want to really deep dive into Python, there's a lot of free courses out there through like Code Academy or what is the other good ones that there are. Basically, a lot of those free online courses will cover the basics of Python. Sometimes, if you are somewhat of a developer, you can sometimes just pick up a book and read it. That's how I learned how to do Python. But there are a ton of free classes out there. But definitely go to developer.cisco.com. We do have some of our learning labs that will help you actually do some of the programming yourself. Okay, so somebody asked for that the resources. Let me go flip over to the URLs. If you go to develop